We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, everybody. Oh, what happened to my avatar? There we go. Okay. Hello, everybody. It's me, the Shy Hat, and we're doing HackerFrogs AfterSchool. And I see, let's see, Mibina Craft. Hello, nice to see you here. 187 Rogue, and who else? Who else? We got Adolein. Thank you very much for coming by, and let's chat some more. Not that active, but I use those platforms. Awesome, awesome. So we're just talking to Adelaine, who has recently gotten a job as a pen tester. That's great. That's great. What are we doing today? So we're going to be covering 4 topics today, like usual. So this is what are we doing? This is October 17th. October 17th. This is Variety Fridays, and we've got a schedule that we do for our live streams every week over here, over at Reddit. There's also a Discord if you want to join the Discord. I'll just drop that link. There you go. And what are we doing today? So originally we're going to do some HackerFrogs hacking history today, but you know what? I think I really want to do some programming challenges instead. So we're just going to we're going to forego the history. We're going to do some Leetcode programming challenges. We're going to be writing some We're going to be solving some challenges in Python, and that's the first thing we're going to be doing in this stream. The second thing we're going to be doing in about an hour or so is we're going to be doing HackerFrogs AfterSchool Web App Hacking, session number 5. So this session is going to be focused on learning how to use the SQL programming language, and that's the language that most databases use on the internet. So we need to learn how the language works in the first place before we can start hacking against it. So that's what we're going to be doing in the second hour. In the third hour, we're going to be doing some demonstrations for binary hacking. So binary hacking is a current passion of mine. I really want to teach everybody how to do some easy binary challenges, and those are going to be over at PicoCTF. And that's going to be the third hour of today's stream. In the fourth hour and the fifth hour, and we'll see, we're going to be switching this up as well. I realized at the last moment that the Leviathan CTF lab over at Over the Wire, this is more of a Linux privilege escalation type of CTF. So instead, we're going to be doing the Narnia labs. The Narnia labs are more focused on binary hacking, which is what we're going to be focusing in on today a little bit more. Okay, so everybody, let's go ahead and get started. So I'll put 60 minutes on the clock, and then we will start into our lead coding. So if anybody's wondering what coding has to do with cybersecurity and hacking, very oftentimes very oftentimes you're going to be encountering scripts, and you're going to be encountering code while you're doing your cybersecurity work. So we did a short Python course, but of course that short Python course isn't going to be sufficient to teach everything about Python. So what we're going to do is, hello, Fixit, nice to see you here. The 18th, it's the 18th over here already. Well, I mean, I live in the past, and you live in the future, Fixit42. So anybody who doesn't know, Fixit42 is another cybersecurity content creator. Let's give her a shout out. There you go. Okay, so everybody who is not familiar with Leetcode, Leetcode is it's a very popular website for learning about how to code and for programming challenges. So you can do the programming challenges in any language you like, and what we're going to do is we're going to go down a list of some of the challenges that I've bookmarked. So let's see. Let's start with this one first. It's called Score of a String. And everybody, if you have an account over at Leetcode yourself, you can join in along with us while we solve this challenge. Okay, so let me get that link. There you go. All right, so let's see. The interesting thing here is that we have a coding window. All right, thank you very much to GX000 for redeeming the Budweiser frogs. You know, I forgot to ask GX000, how did your Thanksgiving go? Thanksgiving was on Monday over here in Canada, and GX00 was talking about how he was going to be visiting some future in-laws. So I'm wondering how that went. Apparently you didn't die, so that's a good thing. All right, so what's happening in this challenge? Okay, so in each one of these Leetcode, I've actually never done much Leetcoding before, so I'm actually discovering Leetcode along with everybody else. So what's going on here? Let's see, my fiance told her mother that I've lost 25 kilograms. Her mother was like, it does not look like it. That's, you know, I hope everything goes better in the future. As far as interactions with your future mother-in-law. There you go. Okay, so what's going on here? So this is an easy challenge, and you're given a string S. The score of a string is defined as the sum of the absolute difference between the ASCII values of the adjacent characters. The adjacent characters. Return the score of S. So let's see, example S equals hello, output equals 13. So s equals hello. So the score is going to be absolute value of the difference, absolute difference between ASCII values of adjacent characters. You doubt it. Well, I mean, we're all hoping for you know, good interactions and good relationships between people. So the ASCII values of the character in S are H equals 104, E equals 101, L 108, and O 111. So the score of S would be, so the adjacent characters, huh? So the absolute difference. So it is H, which is 104 minus 101, plus 101, which is E, minus 108, which is L, plus the same thing because there are two L's, and then we add up all these absolute differences, and then we get the score of 13. Okay, and so I guess the first thing we need to do, class solution, we're not doing C++, we're doing Python, so we need to change our language over to Python 3. Okay, so class solution. Okay, so class solution, inside the class of solution, it's going to be, we're going to create a function. So the function is called score of string self s string. And what is this? Hold on. I think this window over here we can get rid of, right? Well, I mean, I don't think we need it. Okay, so score of string self s string integer. Okay, so how do we handle this? So the first thing we need to do is we need to... Okay, what's going on? So here's one problem I have immediately. I don't deal very much with classes in Python, so I need to figure out how to work inside of these classes. I mean, it shouldn't be too difficult, but let's see. So I mean, we're just making a function inside the class. Score of string self s string integer. Saved upgrade to cloud saving. Okay, so constraints. So s.length is the minimum is 2 and the maximum is 100. Dienkiako says just act like usual, don't care about the self, like a regular function basically. Def score of strings s, okay. And outer organism. Okay, hello. Outer organism says I sent 400 bits on Twitch. I hope it helps. I don't know what it does. So 400 bits is the equivalent of $4 American because each bit is like 1 cent. So 100 bits is like $1. But I very much appreciate the any bits that you send. Thank you very much. Outer organism. Fixit42 says this could be a great way to learn a language. I just started looking at Rust today. I guess I'll do it. I mean, there's lots of free challenges over on why do we have ads? I guess we have ads because we're not we're doing the free program. But yeah, thank you very much, Outer Organism. Let's see. Have you seen this question in a real interview before? I mean, I haven't. Okay, so the s.length is a variable, and the length is going to be minimum 2 and maximum 100 is what I'm looking at here. Sick in the Mind, hello, nice to see you here. Good afternoon to you as well. So we're doing some Leetcode, and if you wanna take a look, I think anybody should be able to go to this link. But let me check really quick. Okay, let's do a private window. Let's see if we can just Oh, I guess they're gonna ask you to log in. No, it doesn't ask you to log in. Okay, so you don't need a membership to do the challenge. That's great. Okay, so S only consists of lowercase English letters. All right. So what we need to do here is we need to define a score, right? So S is going to be like a string. So S is a string. We need to, in this challenge, we need to score, we have to give a score or return a score for the string S. I mean, the very end of the function is going to be return S or return score. And, well, I mean, that's getting a bit ahead of ourselves. Okay, and so the score is equal to the absolute difference between adjacent characters. I mean, you're talking about we're only talking about the next adjacent character, right? Of adjacent characters. So we're going to receive a string, and the string is going to be S. And I guess what we need to do is we need to run a for loop. Jason IT Solution says hello. Hello, Jason IT Solution. Nice to see you here. I got to tell everybody right now that I'm not really much of a programmer, so this is just my my attempt to learn how to program a little bit better. So for length, for length of S, do something. So for length of S, we're going to define a score. Score equals it says login to run or submit, by the way. Login to run or submit, really. So I guess you can't run the thing unless you're logged in. You can see the challenge, but I guess you need to log in before you can actually solve the challenge. Second of Mind says, I do have an account already, so no biggie. Yeah, I mean, Leetcode they do have a free tier, so you can do these challenges with your free account. So I usually like to do exercises that people can do for free. So this is an example of that. And okay, so score equals, let's see, so the ASCII values of the adjacent characters. So to get the ASCII value of the adjacent character, it's so for length of S, do something. So it's going to be maybe we can do value 1, and value 2, because we need to get the values of the two characters. So for length of S, S let's see, maybe for I in length of S, for I in S, or I guess for letter in S, value 1 equals S letter, and this will also be S letter. And what do we need to do? We need to get the decimal ASCII value, right? And the decimal ASCII value of something in Python can be retrieved from, what is it? Was it C? Let's see. So Python, let's see. Letter equals A. And then we do print letter, is it CHR? Or is it ORD? No, it's ORD. Okay. Yeah, it's ORed. Thank you, Denkiato. Thank you. Okay, so we just need to ORed each one of these letters. Where are we? Where's my Leetcode? Okay, so it's going to be ORed letter and ORed letter ORed at letter +1. Can we do it like this? Okay, so if letter equals, or word equals hello, and then we do print ORed word element 0 + 1, then we get E over here, right? But if we don't do +1, it's just it's 104. Okay, cool. So, I mean, this seems to work. Score equals value 1 minus value 2. Return score. So, class solution, test case, test result. I guess we need to define score as well in here. So score equals 0 because we start with 0, and then each time we run the thing, it's going to add to the score. So score plus equals value of 1 minus value of 2. So this should run through each one of the letters in the S string, and then it'll return the final value afterwards. Let me see if I can create this in another window. Can I copy this? No? Hold on. Okay, so we need to create a new class object, right? So let's see. Let's just say solve equals, what was it, solution? Solve equals solution. And then we do, sorry, I need to, I forget how to instantiate new class objects. So Python create new class object. Okay, so I mean this is creating a class, and then object1 equals my class with values. Okay, so the values are my class, object1 equals my class, value something something. So it's going to be solution with run equals solve.score of a string, score of a string, print run. Run equals solve.score of a string, score of string, and let's just let's see, we need a string. Score of string is self, s equals string, and so s equals, I don't know, just hello, for example. Okay, and I think this is what we're looking for. I don't know if this is enough, but we'll give it a shot. Okay, so we'll just write this out. We'll make a coding window over here, and we'll make another window to run the code. Okay, so what do we got? What do we have here? So string indices must be integers, not strings. String indices, so s.letter must be integers, not strings. So letter is actually oh, letter is going to be interpreted as a single character. Okay, so it's going to be ord of the letter, and it's going to be the ord of... Okay. The letter is an actual character in this case. So you should do for letter in range 0 length of s. Okay, so for letter in range, start at 0, length of s. So value 1 equals ord letter, and the letter is, then ord 2 is the order ord. Now how do we iterate this? Seg faults, hello, nice to see you here. What is up? What is up? We're just doing some Leetcode stuff. Leetcode stuff, and if you want to take a look at the same Leetcode problem that we're doing right now, it is this one right here. Okay, so value 1 is the ord of the letter. That's the ASCII value. It's an integer. Now, how do we get the next letter? The next letter should be ord s. It should be s. How do we reference the letters order? So this is going to be for each letter in the string. The string, we need to get the one next to in the next letter. Ord of value 1 is wrong. You should probably change the name of the letter because it's misnaming. It's misleading, more like index number. Let's see. Ice-T says, what else should someone else be doing besides CTFs to retain knowledge? Do you think doing enough CTFs will help cement important commands? I think... Okay, let me address Ice-T first. So what else should somebody be doing alongside CTFs? I think you should be doing CTFs. You should be doing a lot of note-taking, and the thing is that if you're not doing your good note-taking and your good report writing, your good documentation while you're doing your CTF exercises, it's kind of a wasted effort, because the thing is that, you know, you'll solve challenges in CTFs, and you'll do your research. You'll learn the commands to accomplish the goal in the CTF challenge. But if you don't document how you did it, you won't be able to come back later and see how you solved the task. If you were to come back, like way down the line, maybe a couple of months or a couple of years after you solve that challenge. So it's important to do your good documentation. As far as what else you should be doing alongside CTFs, I'd say it really depends on where you are in your cybersecurity journey. So if you're, I haven't referenced it in a while, but the starter pack over here, it's got some really good links for technology stuff in general and computer networking, and those are fundamentals. So fundamentals of working with technology and working with computer networks, those are some good things to learn alongside. Okay, everybody, we've got a break right now, so let's go ahead and do some ads over on YouTube. Just a second. Okay, and we're also going to be taking a little break over here to have some water. But in the meantime, enjoy the birds. Okay, so let's put the birds away. If anybody is wondering what kind of birds these are northern flicker woodpeckers. They're really, really cool birds. Okay, put them away. Okay, so what are we trying to figure out right now? So we're trying to figure out how to reference the next iteration inside of the length of s. So s is going to be a string. What we need to do is we need to get the current letter in the string and the next letter in the string. And then we need to determine some sort of score in order to get the solution and submit it to Leetcode, and then complete the challenge. But we've run into a little problem here. So value 1, we're trying to take value 1 and then subtract it from. We're trying to subtract value 2 from value 1. So the current letter, the ASCII, the decimal ASCII value of it, we're going to subtract the ASCII decimal value of the next letter. So why not Segfall says, why not for I in range, length of s minus 1? Okay, so these are going to be letters. For letter in range, start at 0, length of s minus 1. I guess yeah, that's true, because length of s minus 1, because we're not going to be calculating the final letter. Okay, so letter in range. Value 1 is going to be ORed of the letter, and we need to subtract the value of the letter, well, the next letter, but I'm not too sure how to reference the next letter in this case. So I mean, let's see. Alright, so if we have, say we have a string. Oh, this is a Python problem. Say we have a string and hello, and we have a for loop, four letter in string. We want to subtract the ASCII, the decimal ASCII representation of the letter of the next letter in the string from the original letter. How would we do that? Probably change the name of the iterator letter. It's misleading. So, I mean, it is... Hold on. So the iterator is not letter. I mean, it is a letter, right? So if we print the letter, it's gonna give us an ASCII character. Or it expected, wait, what's going on here? So line 6, okay, hold on. So let's do nano again, but let's give it some lines. So line 6, or it expected letter, expected string of length what, but int found. So is this, okay, I'm getting confused. So is this, so this is an index, right? So letter is a, so in this case, I is an index. Print I. Let's see. What are we doing here? Okay. Or it expected string. So this is just an... So is this just going to be like 0, 1, 2, 3? Let's see. Adwitia Singh says, "Would you like to check my portfolio?" I can't do that on stream, but why don't you go ahead and give me a message in the Discord. Here, hold on. Here's the Discord link. Okay, so let's comment this stuff out. Zero, 1, 2, 3, 1. Okay, so for I in range, these are just the indexes, but the indexes don't give us any info. What we really want is we want the string or the character that's associated with it. Okay, so enumerating with index is what's going on here? Sorry. I was asking a lot about binary hacking stuff. Let's go down to the bottom. Okay, enumerating with index, string equals hello. For I letter in enumerate string. Enumerate string, I guess what we're doing... Wait. Is there an enumerate function in Python? I didn't know about that. Python enumerate function. The letter will be the numbers now if you use range. Okay, so the AI is just overcomplicating stuff. So enumerate function is a built-in function that simplifies iterating through iterable objects while simultaneously accessing both the index and the value of each element. Actually, I think enumerate could come in handy here. Because what we need is we do need an iterable, and we do need the value here. So, I mean, if we run let's see. So for I in range, let's just get rid of this first. So if we run enumerate on S and what was it, start 0? Start equals 0. And let's just say for I in S, print this thing. Okay. So the letter will be numbers now if you use range. Fixit42 says, I'm pissed at ChatGPT. Rust syntax. Yeah, I mean, ChatGPT is not very... It's probably not as good at doing Rust stuff as it is at doing Python stuff. So if we just write this out and try running some Python... Inconsistent use of tabs and... Oh, okay. So I need to make sure that we use spaces only. How many spaces is this? Oh, these are tabs. Tab. Okay, this is line 4. Oh. Need to make sure to do consistent number of tabs and spaces. So we're only using spaces in this code. We do not use tabs. How many is this? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'd use 4 spaces. It's messy with ASCII and bytes and stuff. Rust seems to be all UTF-8. Well, learning stuff. Yeah, the important thing is that you're learning stuff. And Santa Vice, hello, nice to see you here. Okay. Okay, so I mean... Enumerate iterable, start 0. Iterable is any object that can be iterated over, such as a list. Start optional, the starting value of the counter index by default it is 0. I mean, if it by default it is 0, then you don't need to... Okay, so instead of manually initializing a counter... So if you do for index item in enumerate my list, so index item, we could probably copy this as well. For So is this just enumerate or is it enumerate? Not enough values to unpack. Expected 2, got 1. So S is a string hello. Okay, so Second the Mind says I beat 100% of the submissions. That's crazy work. What? You beat 100% of the submissions when you submitted your answer for this challenge? Dang. Dang, Second the Mind, that's pretty good. Okay, so line 4. So this is line 4, for index item in S. So index item in S is hello. S is a string, so it should be, well, for index item in enumerate. Oh, okay. So they want the enumerate up here. Print, I guess in this time we do print index item. Let's see. I failed like 8 times. Failed it like 8 times. How much memory? Memory? Why are we talking about memory right now? Okay, so 0H, 1E, 2L, 3L, 4O, and then 0. Well, return score, I guess. Yeah? Okay, so what are we doing here instead then? So for index item in enumerate S, we want to do, well, we're not printing. I guess we can also print the things. But we're also going to do the values over here as well. Ronan, hello, nice to see you here. Segfault says that Leetcode shows you how much memory the code used on submission. Oh, okay, that's directed towards Sick in the Mind, not towards me. Okay. Ronan, hey, hello, nice to see you here. Just writing some code over here. How about I hack the planet for you?
Hack the planet! Hack the planet!
Okay, so value 1 equals ord of the item. And then we're going to do ord of the ord of, are we doing s.index s.item. How do we reference this? Zen says, hello, how's it going? CPU beat 100%. Memory only beat 29%. CPU beat 100%. Leetcode. Yep, we're doing some Leetcode. So we're still running into a little problem. Value 2, we can get the order of the item. That's fine. Value 2 equals the index plus 1 how do we reference this? So is it like s.index plus 1? and then we ORed around that. S index plus 1. S index plus 1. Does that work? S index plus 1. Okay, well, let's give this a go. What is happening here? So score plus equals value 1 minus value 2. Unsupported operand types for integer, and string. Integer and string. So this is line 8, and so this is line 13, which references line 8. And S index and S index plus 1 will give you an ASCII character. Shota Vujimori, hello, nice to see you here. Yeah, okay, so if this is an ASCII character, then ORed item, I guess we ORed wrap this up. If that's the case, then this should be the solution. Index out of range. Okay, so for index item enumerate S, we would want to I think with enumerate you can also slist ORed character for character in S. Now you got turned into ORed, but doing that I created a list of decimal values on the fly instead of doing the conversion later. So I think you can, inside of enumerate, you should be able to specify a stopping point as well, because you can specify a starting point. So start equals 1, and maybe, so let's see, Python enumerate function documentation. So built-in function enumerate, Python enumerate function. Okay. Iterable and start. You can define the start, but you can't define the end. Because I want it to end before the last letter. Because if we do the last letter, then the last letter is not going to work because the last letter doesn't have a +1. So we have to specify that it has to stop. It has to stop before the end. So you got HELLO, but when we get here, we would encounter an error because there's no stop. Since Cloud wanted to use enumerate, I wonder how they did it. That's a good point, Dunkiato. Thank you. We should go back. Okay, enumerate with index. If I is less than length of string -1, check if there's a next letter. Oh, interesting. Result ORed letter minus ORed next letter. For I letter in enumerate string. Check if there's a next letter. If... Well, I mean, I guess we just adapt this code then. Well, I mean, Okay, let's comment out this part of the code. This is looking really messy. Oh well. So if string if I is less than the length of the string minus 1, and I guess the length of s minus 1, if I index check if there's a next letter. Next letter equals string I or s I plus 1. Result equals ord letter minus ord next letter, but they don't define next letter. Actually, no, they do define next letter. Okay, Dankiato says, I see no point of using enumerate, to be honest. Well, I mean, you can do this stuff in a lot of different ways. I'm just trying to figure out a way of solving the problem, because I'm trying to find ways to become better at solving problems using coding. Okay, so result equals this thing, and then we just need to do score plus equals result. And then finally we have to return the score. Okay, and let's see if this code works. I is not defined. Do you mean ID? Okay, so item. Or this is index. Name letter is not defined. Ord letter. Letter is, this is line 7. In this case we're doing, let's define it up here. So we don't have the word item in the rest of the code, do we? I don't think we do. Okay. -7. Okay, so we got the result -7. Is this correct? So we got -7 in here. This is one of the test cases in the challenge here. So x equals hello, output should be 13. So h equals 104. H is 104, right? You need to use the abs function to turn the score into a positive number. Turn the score into a positive number. Well, I mean, if it's a positive number, then it should. I mean, if it's just a problem of returning a negative number, this should be -13. So I'm not too sure where the code is going wrong here. Okay, on line 8, try doing score plus absolute of the result. Oh, okay. Wait a minute. Can any of these be... What are they looking for? Absolute difference. Right. Okay. So I think this is an important distinction here. Thank you, Denkiato. So abs result. So we will adjust the code, run it again. Now we get 13. Okay, so we just need to make sure that the class is correct. So if the class is correct, then we should get. Hold on. Then we should be able to solve the thing in Leetcode. So they just want this. faster if you skip the extra line and return the abs. Do we have like an extra print in here? I don't think we do. We don't have any. Yeah, so there's no print statement in here, so we can just paste it in. Oh. Hold on, let me just delete everything. We can get rid of the comment. Okay, so if we've got this, we can just run the thing, right? Test case. Wait, are we supposed to drag this thing? Test case 1, hello. Test case 2, Zaz. Okay. Test result. You must run your code first. So run the code is this button here. Okay, so output 13, expected 13, great. Case 2. Output 50, expected 50, that works. Missing the play button. Yeah, just the play button's up here. I think we can submit this. I mean, it's probably not super optimized, but it's accepted. Submit. Okay, so what happened here? So accepted, beat 7.4% for runtime. Memory beats 99.54%. I guess that's good. All right. Well, I guess we should record our solution and then we should move on. I don't think we've that took like an hour. Wow. That shouldn't have taken an hour. Oh well. Okay, let's so for every one of these exercises, what we want to do is we want to create a write-up so that we can look back at our the exercises that we finished, and we could reproduce it. 6at42 says my first Rust program solution. Okay, I mean I don't I don't know Rust, so I can't really evaluate the Rust program. But what did Leetcode tell you? Okay, I guess I can add Leetcode to my growing number of different platforms that we've got for walkthroughs. Leetcode. Leetcode Easy. And what is this one called? 3110 score of a string. Okay, code. Score of string. Okay. Score of a string. Well, I mean, score of string is the function, but the challenge is called score of a string. Okay, so the URL of the challenge and the challenge description. Okay, let me grab both of those. And we'll grab the description, and then we can be done. Okay, commit the changes. My typing is checking out today. I've been in reports too long today. Hope you have some time to relax this weekend. Sick in the mind. Fixit42 says ChatGPT was talking about Rust using UTF-8, so I think this is for math with extended ASCII characters to be correct. Hopefully. Oh, okay, okay. But yeah, Fixit42. Hope you're having Oh, you're in the morning already, right? Gonna take some Battlefield Battlefield 6. No worries, no worries. Gotta unwind. Yeah. Okay, so Leetcode. I think we're pretty much done with Leetcode for today. But everybody, this is what we're trying to do. We're trying to get better at coding. So we're gonna be doing some more of these Leetcode solutions, or some more of these challenges. So let's see. I think. I wonder if my favorite list is something we can privately see. You can publicly see. Oh, this is a private list. I guess I could make it a public list. Can we make this public? Private? Now how would I guess I can edit this? This is my favorite list. Can we make it public? Make public. Yeah. Okay, so if you want to take a look at the challenges on the list, you should be able to open that up. Let me try that one more time. Okay, cool. All right, everybody, that was the Leetcode part of the stream. Let's go ahead and move into the second part of the stream. Second part is going to be HackerFrogs AfterSchool. We're going to be doing a SQL crash course. So if you ever wanted to learn how to look up stuff in databases, this is the time for you to shine. Okay, let me close out my Leetcode stuff, and let's get into HackerFrogs AfterSchool. Oh, I guess I'll turn off the music for this portion of the stream because it's supposed to be educational, and music might distract some people. Okay, everybody, this is HackerFrogs AfterSchool, Intro to SQL with SQL Murder Mystery. You can solve the murder mystery. We're not going to be solving the murder mystery, but we're going to be using the murder mystery application to learn more about the SQL database language. Okay, so this is the 5th workshop for Intro to Web App Hacking. Let's take a few moments to review the concept we learned in the previous workshop. So in the previous workshop, we learned about OS command injection. So OS command injection is a web app vulnerability where arbitrary OS commands can be performed on a web server through a web interface. So OS command injection can often lead to complete compromise of the web server, and if so, the web server can be used as a foothold to attack other machines on the network. So this is one of the most serious web app vulnerabilities, but that was last time. So this time, we're going to be doing the SQL database language. So people might be asking, why are we learning a database language if we're supposed to be learning about web app hacking? So let's answer the question first. What is this language we're going to be learning? This is called Structured Query Language, otherwise known as SQL or SQL. It's a programming language used for managing data held in relational databases. So simply put, SQL allows users to access and manage data contained in relational databases, which are common components in most web applications. So the real reason why we're learning SQL is because most web applications use SQL and SQL databases, and if they're insecurely coded, then we could potentially hack those SQL, the SQL software that's running on the website. So why are we learning about SQL? Web app hacking is, as far as web app hacking is concerned, insecure implementations of SQL in web apps can lead to a very serious vulnerability called SQL injection. So we will learn about SQL injection in a later session, but first we have to learn how to use SQL in its intended manner before we learn how to abuse it. So we're going to be learning through a game. In a web browser, we're going to be navigating to the following URL. So this is mystery.nightlab.com, and this is the SQL Murder Mystery Challenge. And I think we've got it. Hold on. I've got some links. Okay, this is session number 5. If you want to take a look at the stuff that we're, this is for little old Bobby drop tables. Of course it is. This is exactly what we're talking about. Okay, so the murder mystery is going to be at this link over here. Okay, so we're going to be talking. So this is the murder mystery over here, and what does it say? So this is a walkthrough for SQL beginners. We're not necessarily going to be working through the exercise here, but we are going to be talking about some of the information that's in the web app here. So it's going to be all sorts of good stuff. We're going to be talking about the different parts of SQL and how we can interact with that. So let's talk about SQL database structure. So when we're talking about SQL, we're dealing with databases. So the largest unit in an SQL system is the database. So a database is a bunch of different tables that are all related to each other in some way. Well, supposedly. But yeah, if you've got a database over here, it might have a bunch of different tables, and inside those tables there are some smaller parts. Let's talk about it. So the largest unit in the SQL system is the database, and inside the database there's going to be one or more tables. So in this case, we've got, oh, looking at the wrong thing, I think. So here are the tables inside the database, inside the application here. So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 9 different tables in the database. And tables themselves can be subdivided into 2 elements. So inside of each SQL database table, there are columns whose names identify the data that should be entered into them. So we've got a bunch of columns over here. We've got ID, name, license ID, address number, etc., etc. And we got rows, which contain data entries that correspond to the columns that they fall under. So we've got this column here. It's got an ID entry, a name entry, a license entry, and so you just need to know that the columns are the names of the information that's entered into them, and the rows are the values of the columns. Okay, so we're going to be talking about some SQL statements. So this statement over here is going to be used to retrieve all rows from a specified table. It uses 2 SQL keywords, select and from. So basically an instruction that we give to the SQL system is called a statement or a query. And we want to construct these in order to retrieve specific information. So let's go ahead and try this. So it's going to be select star from person. And we're just going to go over to the web app. And in the web app, we can go to any one of these windows because all the windows here are connected to the database. We're going to modify this query here and select star from person. So star in SQL parlance is basically selecting all of the columns. So star refers to all columns from the person table. You can, in this application, you can do this across multiple lines. And if you do it across multiple lines, it makes it a little bit easier to understand what's going on. But in most of the time when you're dealing with SQL applications, when you're hacking them, you do not have the luxury to split up your lines. But anyways, if we run this query, it retrieves all of the columns from the person table. So the person table has the ID column, the name column, the license ID, address number, address street name, SSN, etc. from oh, you know what? I forgot to set up my time. All right, so we've been at this for 10 minutes already. Let me start the timer. Okay, so this is a basic use of the SQL system. You just need to specify a table. So from person, and then you can just select everything from that table. So star means everything, but you can also retrieve specific columns. So if you want to just get the names from this particular table, you can just select name from person, and that's just going to retrieve all the rows under the name column. So if we run this instead, we just get names. We can also get multiple columns at the same time. So we could do select ID name from person, and that'll get the ID and the name columns for each one of these entries over here. Okay, so let's go back. So the select command is the most common SQL command, which returns SQL entries depending on what additional parameters are provided. So select basically means retrieve something. So that's the select command, and then the from command. The from command specifies which table to retrieve the data from. So from and then the name of a table, so person or what other tables exist. So we got the interview table, the get fit now member table, the driver's license table. So we can reference each one of these tables when we do our statements or queries. So we've got the wildcard character over here, the wildcard star character, asterisk. The last important detail about this statement is the asterisk wildcard character, which indicates all columns. So most of the time, if you don't know the table, if you don't know the information or the column names in the table that you're looking at, you can just select everything by using the star wildcard character. So let's see, let's do some basic table selection practice. So retrieve all the columns from the interview table. What is the first number in the person ID column? Okay. So I want you to give this a try. Retrieve all the columns from the interview table. So it would be select star from interview. What is the first number in the person ID column? Can you tell me? If not, we're going to be doing this in just a second. But I want you to give this a try first. So it's just go to any one of these, go to this page, go to any one of the code windows. So this code window or this code window or this code window, and then select everything from interview. So the question is, what is the first number in the person ID column? So person ID column, this is the number right here. And yeah, so this is what is the word? Accessing different tables. So the answer is 28508. Now retrieve all of the columns from the driver's license table. What is the first entry in the car make column? So this is very similar to the previous one. You're just going to replace the table name, and the table name that we want is drivers underscore license. And we want to get the first entry for the car make column. What is that going to be? It's probably the name of a type of car, so like Toyota or BMW or something. Okay, let's go ahead and do that ourselves. So select star from car make. Was it car make or driver's license? It was driver's license. Okay. Run that. And let's see, we got car make, we got Acura. 3D Code Warrior, hello, nice to see you here. Welcome, welcome. Let's give you a fun video redeem. How about a Nyan Cat? So we're currently taking a look at this website, and we're learning how to do database queries. Because, well, database queries and the SQL language that is used to make those queries, it's a big part of a specific type of web app hacking. And that web app hacking is called SQL injection, which is something you can do to get all sorts of information from databases. So we see that the first car make row over here, it says Acura. Okay. So the answer is Acura. Great. Let's move on to more advanced statements. So selecting rows with specific values. So most of the time when we interact with databases, we want specific information, and we can search for that with the where filter and the equal character. So in this case, we could select all the columns from the person table where the name equals Courtney Calderwood. Courtney Calderwood, that's a bit specific. Let me see if I can get that going right now. Where are we here? Okay, so select all columns from person where name equals, what was it, Courtney Calderwood. So in this case, it's only going to return columns, or sorry, it's only going to return rows from the person table if there's a name. In the name column, there's the entry, there's a string Courtney Calderwood. No data return. Did I spell that incorrectly? Hold on just a sec. Star from person, Courtney Calderwood. Oh, I didn't spell it correctly. Okay, so this gets us just the row with Courtney Calderwood, and we get all the information about this particular person. We got the ID, the license ID, address number, street name, social security number. If anybody's wondering if what we're doing right now is legal, this is all fictional. So there's something like 10,000 different names in these tables, but this is all made up information. We're not actually hacking into some database right now. We're just learning how to use database software. Okay. So the where filter allows very specific information to be returned by the query. So where is a binary. So it's either it is or it isn't. So the equal operator used with the where filter is going to return exact matches. If the contents of a row differ by even a single character, the match will not return. So the K in the above example is not capitalized, so a valid match is not found. So select star from person where name equals Kinsey Erickson, but we use a lowercase k instead of an uppercase K, and then we don't get anything back. So when you use the where keyword, you have to be very specific. So same thing here. If we do lowercase k Courtney Calderwood, then we don't get anything. Or if we change any one of these, the cases for any one of these characters, we also don't get anything. But if we use the correct string, then we get it. Okay. So where statement practice. So we're just going to be doing a little bit of practice with the where statement here. So look in the person table and look for the name Hannah Beverage. Let's practice getting specific rows using these criteria. What street does Hannah live on? So I'll give everybody a moment or two to try this out themselves. So select from the person table where the name equals Hannah Beverage. You should see one entry, and can you tell me what street does Hannah live on? Okay, we can start start this up as well. So person table Hannah Beverage. Just go over here. Hannah Beverage. And we see that the address street name is Ailing Circle. So select star from person where name equals Hannah Beveridge. Now look at the same person table, but this time use ID 10914. What is this person's name? So in this case, we want to look up this person by their ID, the ID number in the database. So how will we change this? So select star from person where it's going to be ID equals 10914. So let's go ahead and try this out. So let's see, 10914. Where ID equals 10914. That's the correct number, right? Yeah. Okay, so keep in mind that that SQL is a programming language, so you need to make sure that numbers don't have quotes around them, but strings do have quotes around them. So if you're looking for Hannah Beveridge, this is a string, you need to put quotes around it. But if you're using a number, you don't need to put quotes around that. So when we run this, we get another name. We're supposed to get the name. In this case, we're looking for the name, and the name is Cinderella Coachman. And this is associated with the ID 10914. Okay? Great. So let's see. Look at the same person table, but this time address street name equals Deer Cliff Circle. What is this person's SSN? So like before, we're using where, select star from person where, but in this case it's address street name equals Deer Cliff Circle. What is the person's SSN number? So let's go ahead and do this ourselves. I guess I can just copy this exact thing. If you wanted to give it a try. Okay, so address street name equals Deer Cliff Circle. So we can run this, and so Harley Dearmore is the number, and the SSN is the thing that we're looking for. It's this one right here. So here's the thing. Another thing that we should note about SQL language is that all of the statements should be terminated with a semicolon. So in this application, it really it helps us out because it'll give us it'll let us return entries even if we don't put the semicolon at the end. But in most applications, you need to make sure that there's a semicolon at the end. Khalid Anu says, good evening from Sierra Leone. Hello, nice to see you here. Khalid, welcome to the stream. We're just learning about SQL database language right now. Okay, so let's go back. So great, let's move on to more advanced SQL statements. So what else can we do here? Really love your stream at night. It's not night where I am, but I guess no worries, no matter where it is, what time it is where you are, I hope you're having fun. Okay, so we can also search for partial matches. So sometimes we want to search the database, but we only have vague details, such as part of the name or the last few digits of a number. So what we can do is we can use the like keyword over here. So where name like something more something. And the way we do this is, well, this is how we do it. These type of queries require the where filter with the like keyword. So where name not equals, but we're using like instead. And the %, wildcard character. Thank you very much for following Philint O. Philint O? Let me know if I'm pronouncing that correctly, but welcome to the stream. How about we give you a Hack the Planet?
Hack the planet! Hack the planet! Shut up and get it!
Okay, so the like keyword over here is going to activate the partial matches, and we use the % characters over here to let the system know what is like that we're looking for. FBI. We don't have FBI open up over here. Maybe we'll add it later. Thank you. All right, so let's go over here and what was it? Select star from person where name like something more. So this is what we do. So we'll match anything in the database under the name if there's more somewhere in the string. And the percent sign here is where we indicate where in the string more is supposed to take place. So we've got some people who match this. We got Dearmore, Rushmore, Fenimore, Longmore. Yeah, a lot of people with more in their name. Let's see, gonna get good one day. Can we do some Python next? We did some really messy Python at the beginning of the stream. So if you want to go back and take a look at the start of the stream, we did a little bit of that. I think we're going to be doing more Python coding. When are we going to be doing more Python coding? Probably on Wednesday. Probably on Wednesday we're going to be doing more Python coding. Okay, we got ads running on Twitch right now, so I'll just run them on YouTube. And we'll put on some birds so I can take a little water break. Okay, we'll be back in about 45 seconds. Okay, let's put the birds away and let's get back to the hacking. And Khalid asks, can you share your thoughts on bug bounty because I'm new to bug bounty? Anki Loudwood says, enjoy the bird. What do you call that bird? So that bird is a Steller's jay. And it's my favorite bird. So these are the guys right over here. But anyways, Khalid asked, can you share your thoughts on bug bounty because you're new to bug bounty? Bug bounty is essentially web app hacking, and web app. How much do you know about web app hacking, Khalid? Have you been working at this stuff for a while? And do you have a background in web development? Thank you very much for redeeming the Stellar Jays or the SJ. Redeem Agent 57. Thank you. Okay, so what were we talking about? So yeah. Khaled, let me know what your experience is with web applications, because some people really want to get into bug bounty stuff, but it's kind of difficult to work in bug bounty if you're not already familiar with web applications and how they work, and security training about about web applications specifically. But yeah, bug bounty is I'd say it's a hard life. You need to be good at what you're doing. Otherwise, it's going to be very hard to make money doing that. But good luck to you. And if you have more questions or specific questions, let me know, Khaled. Thank you. Okay, let's go back. So what were we learning about? SQL stuff. Partial matches, yes. The like keyword is used instead of the equal operator when we want to return partial matches as opposed to exact matches. Callan says, I studied computer science. Okay, that's a good start. What other experience do you have to do with the web applications specifically? And we've got the percent wildcard character. The percent wildcard character is used with the like keyword to return anything on that side of the query item. So Most of the time when we want to do partial matches, we want to put the percent signs on both sides just to make sure that we can catch anything inside of here. So let's see, we got more. Like more. I mean, we could look for other stuff as well. If we go in here, we can look for what is a common word that's in people's names. So Smith, we could look for Smith, and we can return all of the names in the database that have the word Smith in them, like this. So just Smith, but we surround it with some percent signs. Okay, so we got Naismith, we got Smith, Smith-Hisler, Smither, Smithers, Clinging Smith, Smithmeyer. Okay, all those other great Smith names. Sick in the Mind says ECMA script. ECMA script. I've never heard of that. Have you had that? Oh, Agent 57 asks, have you done any JavaScript? I guess you're asking, are you asking me, or are you asking the person who's asking about bug bounty stuff? Okay, Rogue asks, sorry to disturb, I'd like to learn from your example here. What is this website? I'm on mobiles. Okay, yeah. Here's the link. The frog on the screen. Do I have experience with JavaScript? I know very little about JavaScript, but I have studied other programming languages, so I can kind of make out some of the characteristics in JavaScript. If I were to read JavaScript, it's kind of difficult. It's not exactly like the Python that I'm used to. Okay, so in the above example, the percent wildcard characters will match to any values to the left and right of the more string. And we can also do the AND clause. So the AND clause is used with the where filter to further restrict to the results returned, only returning rows that match both parameters on either side of the AND clause. So this is something that we cover when we're doing SQL injection. But for right now, we're just trying to figure out how to use it in the intended way. Okay, and Tori says, hi, Shy. Been a minute on here. Hello, nice to see you here, Tori. How are you doing? We're just doing some education on how to use these databases. So let's see. We could do a query where name like Smith and, I don't know, name like Smith, and maybe we can look for something common. So we see here that Adina Naismith lives on Pioneer Hills Road, so we can include that as another filter. And address street name. Address street name is like something. Let's just say Hills. So we're looking for something Hills. Okay, if we run this query, near end syntax error. Oh, okay. The problem here is that we've terminated the statement over here with the semicolon. So let's remove that. Okay, so there's only one name on the list that matches both of these criteria. So if you're wondering what we're looking at for these queries, Fixit42 says, I found the submit button. Mine beat like 100% too. That's funny. Are you talking about, you're talking about Leetcode, right? So Leetcode and was it Rust? Are you doing Rust? Yeah, I think so. Yeah. Okay. Warren Buffett, hello, nice to see you here. What is up? Khalid says, I was a web developer. Okay, that's great. I mean, Khalid, if you were a web developer and you're looking to get into bug bounty, yeah, CyberNerd Dante is here, and CyberNerd Dante is a bug bounty hunter. And CyberNerd Dante says, bug bounty is incredibly competitive, so the top earners have been testing web applications for years. I still think bug bounty is a nice way to supplement learning in the beginning. Yeah, let me recommend a website. So a good website to learn from if you want to learn specific web application vulnerabilities is going to be Portswigger Academy. So Portswigger Academy is the best website, and it's also the best website to learn about web application vulnerabilities and to practice doing those attacks. And it's also completely free. Well, I mean, the software that you would use to do the attacking is not free, but the learning materials are completely free. Okay, let's go back to the lesson. This is the AND clause, so we can use the AND clause to further restrict our search queries. Using the AND clause is very useful when we have a couple of pieces of info to search for, but we don't know the exact details. So for example, in here, we've got where the street address name is something like West something circle, and the name is like Alva something something. We don't know the exact details, but we can feed partial matches to see if we can fish for some matches here. Fixit42 says, check out the Critical Thinking podcast. Let's see, Tori says, I also think you have to be pretty inquisitive and scrutinize well, especially for vulnerabilities like IDOR. The thing about bug bounty is that you should have like a good basis in the way that web applications work in the first place. Otherwise, it's going to be very difficult to do your testing. But Fixit42 mentioned the Critical Thinking podcast. I don't know if I don't listen to that one, but Critical Thinking podcast. Is that a cybersecurity one? The Bug Bounty podcast. Okay. So I'll just leave the link in the chat. Oh, that's a bad looking link. Sorry, let me get you a better link. Here you go. Tori says, I did some labs on Let's Defend on OS Top 10, and I am getting asked to do a walkthrough on my steps. I did some labs on Let's Defend on OS Top 10, and I ended up getting asked to do a walkthrough in my steps. So, I mean, Let's Defend is another cybersecurity platform. Let's Defend. Is it .io or is it .com? It is .io. Okay. This is another cybersecurity education platform, but this one is focused in on defensive cybersecurity. Okay, so we're going to do some advanced search practice. So we've practiced our AND and like keyword searches. We know the name of the person is Jenny something, and they live on Rising something as the street address. What is this person's full name? So this is, let me give the details in chat. Name is Jenny something. Let's see, street address, street name is Rising something. So can you get the full name of this person from the database here? And if you can, let us know. I'll give everybody a couple of moments to give it a try themselves, and afterwards, after a few moments, we'll go in and try this ourselves. Agent 57 says, Let's Defend is now owned by HackTheBox. Wow, HackTheBox sure is doing a lot of moving and shaking, picking up different companies. So HackTheBox picked up, what is it, Vulnlab. So Vulnlab was kind of an advanced Windows Active Directory. Well, no. It was not just Active Directory, but it was another platform where you can do some testing against some lab environments. And HackTheBox picked up that platform, and I guess they've picked up Let's Defend as well. Okay, so we know that the name is Jenny something, and we know that the address street name is something rising something. Rising something. So if we give those two, we get this name right here, Jenny Forbes, who lives on Rising Hill Drive. Okay, awesome. Let's go and take a look at some other stuff. Okay, next we know that the last name of the person is Living something, and they live on something Boulevard. What is this person's full name? Hanky Lodwig says, I use this like SQL injection on some CTF room to solve it. Like SQL injection. I mean, yeah, this is part of the reason that we're learning about this stuff right now. We need to understand how SQL works in order to do database hacking. So what are we looking for? So the last name is Living something. Last name Living something. Street name is something Boulevard. What is this person's full name? So if we go over to the application, we're looking for the last name of the person is Living something. Okay. So it's the same thing. Name like something something living, and the street name is something Boulevard. Okay. Useful for extracting data on blind SQL. Yeah. We were talking about blind SQL in the last session. No data returned. Okay, so we just needed to take the period out of the Boulevard. So we got Hector Livingstone. Great. Okay, so next. Okay, now let's practice a challenge over at PicoCTF. So, all right, so we're gonna move over from the SQL murder mystery, and you know what? If you want to give this a try, the SQL murder mystery is a pretty fun challenge. But the thing is that some the queries that you have to do they get a little bit difficult. But definitely give this a shot if you're interested in learning more about SQL language. Okay, so what are we doing now? We're going to be doing a challenge over at PicoCTF. And which challenge is that? We're going to be doing SQL Direct. Okay, so everybody, this is the link for the challenge. And if you don't have an account over at PicoCTF, you can go ahead and make one because it's free. So what you want to do is you want to log into the PicoCTF website. You want to click on Practice. And then you want to go over to the challenge link. So the challenge link is over here. Okay, so this challenge is called SQL Direct. So connect to this PostgreSQL server and find the flag. Additional details will be available after launching your challenge instance. So I think I'll try to see if I can give everybody access to my server. Yeah. Hold on. Oh, okay. This isn't web access. This is not web access. This is terminal access. But yeah, you should be able to do this challenge from your web shell. And I think you think I should have more subscribers. Well, thank you. I think I should have some more subscribers too. But yeah, here's the information that you're going to need to access the server. And I've just got it for you there. I'm going to go into, well, you can go into the PicoCTF web shell to do this exercise. So just go over to the right-hand side of the screen. There's a button labeled web shell. You click on it. And then it's going to open up the web shell for you to use. So after the web shell opens, you can click on the button beside help. It's called Pop Out Web Shell Terminal. So click on that, and you're going to see your web shell appear in full screen. If you find that the text is too small, you can go over to the corner button over here and you can zoom in and out until the text size is comfortable for you. Okay. All right, so we got the information for how to connect to the server here, and Postgres Pico. This command seems a bit weird. We should just be using this portion right here for our command. So we use this command right here in the terminal, and then the password is Postgres. I don't know what this Pico part of the command is supposed to be here for, but we can go back to your web shell. In the web shell, you can paste in the command. And password for user Postgres, it's just Postgres, Postgres. You won't see anything appear while you're typing in the password. That's normal. And now we're in Postgres. Okay, so what's happening here? So the first thing we want to do is we want to figure out what tables exist in the database. So if we're dealing with Postgres, I think I've got a Postgres like cheat sheet in here. SQL Direct. Oh, you know what? Okay. Let me get everybody like a resource. Postgres SQL cheat sheet. This will let you know about a bunch of different commands that we do when we're using the Postgres system. Ethereal, hello, nice to see you here. How are you doing? Magic words. So let's see. So most D commands, Okay, so most of the time when we enter a system, like we do over here, so help, let's see, you're using PSQL, the command line interface in PostgreSQL. So H to help with SQL commands or help with PSQL commands. And we can do \*. What we want to do is we want to get the table names for this database. Can we clear? Oh, here. Okay. We can do the up and down arrow keys. Okay, so we can just type Q to quit out of here. And not too bad, kind of busy, gonna be lurking per usual. No worries, Ethereal. Nice to see you here. And yeah, have fun. Okay, so we want to look for the tables in this database. We can also look for the database names themselves. So usually in MySQL, you run a command like show tables or show database. Show tables. Unrecognized configuration parameter tables. That's fine. Let's go ahead and we'll do a little search. Tables, list tables from all schemas. So /dt star. So we can also list the databases with the \l. Where are we? We're over here. So \l. Okay, so we have Pico, we got Postgres, and oh, okay. So I think the database that we want to use is the Pico database. So most of the time when you're dealing with databases, you need to select the database you want to interact with. And how do you do that? Over here. List tables from all schemas. We want to use a database. So I guess we want to /c connect to the database. So /c Pico. /c Pico. Okay, so you're now connected to the database Pico as the user Postgres. I guess that's what this was over here. So when you run this command here, you're using the user Postgres and you're connecting to the Pico database. Sorry, everybody. Use Pico. Can we also select use Pico? Hold on. Use Pico. I mean, I think we're already using Pico, so that's okay. We want to get all the tables. So it's, let's see, list tables from all schemas. So /\dt. Okay, so we only have one table in here. AC Always has followed. Thank you very much for following AC Always. You're now HackerFrog. Let's give you a fun video redeem. How about some Nyan Cat? Okay, so from here we can use our SQL commands to get all of the things from the table, from the flags table. So it's just going to be select star from flags, and that's going to output all of the columns and all of the rows from the table. Okay, wait, what did I do wrong? Select star from flags. Okay, sorry. Use Pico. Actually, let me get out of here. Q. Let me log back in and specify the Pico database. Password is Postgres. Okay, so we know that there's a flags table in here, so we can just do select star from flags. Let's see, error at or near select. You missed that last semicolon for syntax. Okay. One more time, select star from flags. It's because of a line break. Okay, here we go. So select star from flags, we get the contents of the table. There's an ID, first name, last name, and address. And we've got the flag in here in the address table. So we could also do, how do we enumerate the columns? So this is another thing. There are a lot of different SQL software out there. So Postgres is one type. It's actually I don't encounter it very often. Most of the time when I encounter SQL, it's MySQL or MariaDB. These are the ones that I encounter the most. But in this case, let's see, Postgres get columns from table. Okay, so to retrieve information about the columns of a specific table, you can use the information schema columns or the /d command in the PostgreSQL. So is it /d and then the name of the table? Hold on. So /d and then flags. Okay, so we get the column names from the flags table. There's an ID column, a first name column, a last name column, and an address column. So the interesting thing here is that it also tells you what kind of information, what type of data goes into these columns. So we can see here that ID has to be an integer, and it's going to be 1, 2, 3. And for each one of these other columns, it can be, these are all going to be strings. So character varying 255, and strange, it also tells you like how the maximum amount of characters you can fit into each one of these entries here. So first name has a maximum, well, all of these have a maximum of 255 characters. But yeah, let's go ahead and copy the flag. So if you're using my instance to get the flag, this part of the flag is going to be randomized depending on the user. So if you use my flag, it's not necessarily going to go through. Anyways, let's go back to the PicoCTF challenge. We will paste in the flag. That's just not enough. Okay. Copy the whole flag, paste in the whole flag, and then submit the flag. And then you're finished. Okay, so everybody, before we go, let's talk about what we learned in today's lesson. So we did a lot of SQL stuff. So we learned about SQL, or Structured Query Language. It's a programming language used for managing data held in relational databases. So when we're talking about relational databases, we're talking about most of the databases that exist on web applications on the internet. We learned about the select command, which is used to select information, and all sorts of other stuff. And what are we going to be doing next? So in the next HackerFrogs AfterSchool workshop, oh, we got ads running on Twitch right now. Shota Fujimori says, "Hi, I have to go. See you again. No worries, no worries." So we got an ad running on Twitch right now, so we're just going to take a little break. So while the break is happening, let's take a look at some birds. How about these birds? Okay, we'll be back in about 45 seconds. Okay, let's get back to the hacking. So this this guy's having a lot of fun. And then there's this little guy. Where is he coming in from? There you go. Anytime you put food out for birds, there's always going to be squirrels coming by to try to eat the same stuff. Anyways, what are we doing next time? In the next HackerFrogs AfterSchool web app hacking workshop, we're going to be learning about SQL injection vulnerabilities with the TryHackMe platform. So we're going to move over from using SQL in its intended capacity to learning about how to hack SQL. And we're going to be using the TryHackMe platform to do that. If you don't have an account over at TryHackMe, let me get you a link. You can make an account over here, and TryHackMe is a very good platform for learning about cybersecurity. There is paid content on there, but the stuff we're going to be using is free, and you can go ahead and use all the free stuff on TryHackMe. And then evaluate whether or not you want to pay for the services or not. You can go completely free on TryHackMe if you really want to, but otherwise, if you're interested in more SQL stuff, here's another link to a game called SQL Zoo, and it's got a bunch of tutorials for learning how to use SQL there. Okay, so let's go ahead and move into the next part of the stream. So this is going to be a demonstration on how to do binary hacking. Lots of fun. Let's set that up. Topic 3 is here. Topic 4 is on deck. And let me I'll do 65 minutes of this. Okay, so what are we doing now? So we're going to be doing a couple of demonstrations for binary hacking. Eventually, I'd like to be able to teach a course on binary hacking, but the first thing we're going to do is I'm just going to give you some demonstrations on how to solve a couple of these binary hacking challenges over at PicoCTF. Okay, so all difficulties, we're looking at binary challenges, and the challenges we're looking for are called overflow. So we're going to be doing the buffer overflow 0 challenge and the buffer overflow 1 challenge. So if you want to get ahead of the game, here's the link for the first challenge. And we're going to be doing, well, we'll see how long it takes for me to demonstrate these two challenges. We might be doing some off-the-cuff stuff for some of the other buffer overflow challenges afterwards, but I've got two that I need to make videos for, so I had to go ahead and do those. Just a second. Okay, we're doing walkthroughs. Let me put on the music again. So we're doing, this is PicoCTF 2022 Binary Hacking Buffer Overflow 0. Okay, so just a second, everybody. I need to pull up my notes. Whoops. Okay, all right, let's do the YouTube intro so that we can start making our video. Just a second. Actually, before we get started with this, if you want to do this along with us, you just need to log into your PicoCTF account, and you need to access the web shell. So the web shell is over here. I think after you're logged into your account, you can just navigate directly to this link in your web browser, and it should open up. It should open up like a full screen view of the web shell. Let me get rid of some of these files. Okay, so we've got our web shell here. We've got it ready. We're going to be downloading some files. We're going to be inspecting them. And let me show you what's going on. Okay. All right, everybody, this is a guided walkthrough for the buffer overflow 0 challenge from PicoCTF from the PicoCTF 2022 event. So this is a medium level challenge in the binary hacking category, and the description says, let's start off simple. Can you overflow the correct buffer? The program is available here, and there's a link. You can view source here, and there's another link. Additional details will be available after launching your challenge instance. So this is a challenge where you need to connect to the server in order to get the answer and complete the challenge. But we don't need to do that right now. The first thing we need to do is we need to download the two files that are associated with this challenge. So the first link is here. We can just hover over it, right click, and then select copy link. After we do that, we're going to go over to our web shell. And you know what? Let's make a directory to work inside of in here. So we're going to make a directory. Let's see. Let's call it buff0. So make directory buff0, then we enter that directory, and then we're gonna make sure that we're in this directory, and then we're going to download the file. So wget space, and then right-click paste, and that will paste in the file address. So give that command, and then afterwards you should see the vuln file in your directory here. So we're also going to download the source code for this file. So we can give the same wget command as the first one, but we're just going to tack on a .c onto the end of this. So the first one is to .vuln, the second one is to vuln.c. Give that command, and you should have 2 files in your directory now. So before we can start messing around with this vuln binary here, we need to make it executable. You can make it executable with the chmod command. So chmod plus x vuln, and then afterwards you're going to see that this is an executable file now. So we should have vuln and vuln.c in here. So vuln is the actual binary that we need to hack in order to get the answer, and vuln.c is the source code that was used to create this vuln file over here. So if we take a look at vuln.c, this is C code. So the binary was compiled using this C code here, and we'll talk a little bit more about what's in the C code in just a little bit. But for now, let's take a look at the presentation file. So this challenge is an introduction to binary hacking memory vulnerabilities. So memory vulnerabilities are flaws in a program which allow the contents of the program's memory to be modified in an unintentional manner. So some consequences of memory vulnerabilities can be seen here. So consequences of memory vulnerability: program crashes, program data leaks, program data corruption, and arbitrary code execution. So memory vulnerabilities are really serious. Of course, the vulnerabilities these days are a bit they're usually not as easy to take advantage of as the ones that we see in CTF challenges like this. But the memory vulnerabilities, we need to learn the basics of these vulnerabilities before we can study binary hacking seriously. Okay, so the challenge goal for this particular exercise is something we like to call crash to win. So the code for this binary indicates that if the program crashes, then the contents of the flag.txt file will be revealed. So we got void sigseg v handler, and it prints out the flag, and then it flushes standard out, and then it exits. It makes use of this sigseg v handler by using this function here, signal sigseg v handler. But we're getting ahead of ourselves. Let's talk about what these kind of crashes are. So sigseg v refers to a segmentation violation, which is a program memory related crash. Segmentation violations happen when a program attempts to access invalid memory addresses. In this binary, it happens due to buffer overflow. So we're going to be talking about the type of vulnerability we're taking advantage of here. It's called buffer overflow, and it's a program memory vulnerability where users are able to overflow a program's memory buffer, which results in other parts of the program's memory to be overwritten. So for example, if you've got if you have a username here and for some reason you're able to overflow information from it, the information might end up in the address portion of the memory or in the phone number portion of the memory, etc., etc. So in this C code, the string variable is created with a set maximum size. So the user can send up to 99 characters and write it to this variable called buff1. However, the program also takes buff1, this variable, and copies its value to the buff2 array, which has a max size of 16 bytes. So if you take a look at the, let's take a look at vuln.c, and we see all the stuff that I was talking about over here. So the vulnerability lies over here. So So the program asks for input, and it saves the input to the buff1 variable. So the buff1 variable has up to 100 bytes allocated to it, and the problem is that whatever you put into the buff1 variable with your user input, it gets copied over with the vuln function here. So the vuln function runs the string copy function, and it takes the input and it puts it in buff2, which is another array, but the buff2 array only has 16 bytes allocated to it, which means if there's more than 16 bytes inside of buff1 and it gets copied over to buff2, then there's going to be some overflow, and that's a big deal. Okay, let's talk a little bit more about this. So we're talking about some buffer overflow, and the reason why buffer overflow can occur in this binary is because it's coded with memory unsafe functions, specifically string copy, which does not validate the size of strings. So these are vulnerable C functions. So there's the getC function, which is used to read a line of user input. This one is unsafe, but the more important one in this exercise is the string copy function. So it copies a string from one location to another, and the string copy function doesn't check to see if whatever you're sending over to the target location is smaller than the maximum size of the location you're copying it to. So if we send more than 16 bytes to the user input, it'll be copied into the buff1 buffer, with excess input overflowing into other memory addresses. So we got buff1, this is what we put in as user input. If afterwards it gets copied over to buff2, but if buff2 gets overflowed, the rest of the input will end up in other memory addresses, and this is where the crash happens. So this will crash the program due to segmentation violation, and this binary is programmed to output the flag in that case. So let's go over to the web shell. Okay, so for this challenge in particular, we need to create a flag file to access. So we're just going to echo out something and create a flag file, because that's what we need to access to prove that we got access to the flag. We got the flag HackerFrogs rule. Okay, so if we get this message by hacking the binary, then we know that we've finished the challenge. Okay, so we're just going to run the vuln binary here, just like this. Okay, input. So we know that we have to send input in excess of 16 characters. So we can count 2, 3, 4. So that's 10, 6. So that's 16 characters. So if we send 17 characters, it just says that the program will exit now. That's because we haven't overflowed a complete memory address. So a complete memory address is usually 8 characters. So we're just going to overflow by in excess of 8 characters. So we're just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 16. And we're just going to add another 8. 1, 2, 3, 4, 5, 6, 7, 8. And then that overflows the buffer. That crashes the program, and we get the flag over here. So we got the flag for HackerFrogs rule. Okay, so what we need to do is we need to recreate this with the binary that's running on the server, and this is how we access it. So buffer overflow. This is the challenge. We need to launch the challenge instance here. After a few seconds, we're going to see that we can connect using this command here. So if you want to try this out yourself, you can try using netcat. But if you're trying to complete the challenge, I recommend you use your own netcat command, because the port number is going to be individualized to your user account. If you use my port to access the program, you're going to get my flag, and my flag doesn't work for you. Anyways, okay, copy that. Then we run the netcat command to access the binary on the server. Input, so we're just going to give the same input here that we did for the offline binary. And we see here we got PicoCTF, overflows aren't that bad, and then, you know, and then the personalized portion. So I'm just going to copy this all. And then I'm going to go over to the challenge. I'm going to paste in the flag. Okay, so before we finish the challenge, let me demonstrate over here what exactly is going on. So if we do, I'm going to use a program called Radare2 to debug this binary. Radare2 debug vuln. Okay, and then I'm going to analyze the binary. Okay, so after we do that, I'm going to print out the main function of the binary here. So print disassembly function at main. This is going to get us assembly instructions for the main function. So the main function is going to copy our user input. It's going to take our user input. So the gets function in C is what takes user input. And we see right before it calls the gets function, it's gonna load in a specific memory address. So the memory address in this case is called var74 hex. And what we can do is we can load in, we can examine this part of the memory. Device says assembly. Yeah, I mean, assembly can be very intimidating if you don't know it. And if you're a bit lost when you're looking at all this stuff, that's fine. Eventually, if you go ahead and study this stuff, you'll learn assembly, you'll learn what the instructions are doing. JSON IT solution is what is input. So the binary runs this C function over here called gets, and gets is going to take in user input, and then you're going to be able to put something into the binary using keyboard input. And whatever is taken in is going to be saved over to this memory location, var74h. So what we're going to do is we're going to run the binary. So DC inside of Radare2 runs the binary. It'll ask for input here. We'll put in 16 bytes, and then we'll add another 8 bytes. Okay, and then we see that there's a crash. So the crash happens here, and what we can do is we can take a look at what's in var74h. So var74h is going to be located at EBP minus 0x74. Okay, so this is where our input ends up. So it ends up over here. So it ends up over here. This is the buff1. This is the buff1 variable over here. So we put it in here. It also gets copied over to buff2, and this is where buff2 is. So it's slightly behind the other variable. Device says, I'm setting assembly right now for reverse engineering. Yeah, if you study reverse engineering, you're going to need to know the assembly language for a bunch. Well, you need to learn assembly language for at least the x86 processor and maybe some other ones. Okay, so what do we have? So this is buff 1. This is buff 2 over here. So we see buff 2 gets filled up, and then it gets copied over to other memory addresses. And because you've put illegal information inside of other memory addresses, the program crashes. And we know from the code that when the program crashes, it gives you the flag. Okay, so let's go ahead and get out of here. Alright, so we've got the flag here, we submit the flag, and then we're done. Everybody, that was a guided walkthrough for the Buffer Overflow Zero Challenge from PicoCTF.org as part of the PicoCTF 2022 event. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. We're not leaving. I just need to say that for my YouTube videos. I say HackerFrogs out, like and subscribe, all that good stuff. Okay, we're going to do one more demonstration for the Buffer Overflow 1 challenge. This one's going to be a little bit more complicated than the previous one. But if you want to check it out along with us, then you would do it from this link. So if there's anything you don't understand about any of the stuff I'm doing, I understand that. Peace out. No, not leaving right now, but thank you. Okay, so if there's anything you don't understand about any of the stuff we're doing during the challenge, binary hacking is the barrier to entry for binary hacking challenges is it's a bit higher than other specializations in cybersecurity, because you need to understand a lot about computer science in order to do these challenges. But I'll try to explain it in as friendly terms, as layman-friendly terms as I can. Okay, so before we start, let me do a little bit of cleanup over here. Okay, so we got the buff0 directory. We don't need it anymore, so remove directory buff0. Okay, let's start the next challenge. Everybody, this is a guided walkthrough for the Buffer Overflow 1 challenge from the PicoCTF website as part of their PicoCTF 2022 event. The description of the challenge says, control the return address. Additional details will be available after launching your challenge instance. So what do they want us to do? Before we do anything, what we need to do is we need to launch the instance. So click on this blue button here. And then after a few moments, it says, now we're cooking. You can overflow the buffer and return to the flag function in the program. You can view the source here and connect to it using this over here. Okay, so we've got a couple of download links. So we're just going to hover over the word program, copy the link, then we're going to go over to our web shell. In the web shell, we're going to create a directory to work inside of. So make directory buff1, and we're going to enter that directory. Then we're going to use wget to download the first file, that link that we just copied. So we're going to see after we download it that we have the vuln binary in here. Afterwards, we can run the same wget command that we did before, but we're going to tack on a .c at the end. This is going to give us the C code source for this particular binary. Okay, and then we're going to see that we've got two files in here, vuln and vuln.c. So we're going to make the vuln binary executable by running this command. chmod +x /vuln. Then we're going to see that the binary is executable now. So before we move on, we can take a look at what kind of file this is by running the file command on it. So file vuln. It's going to let us know that this is an ELF 32-byte LSB executable. Intel 80386. It basically lets us know that this is a 32-bit binary that's in the Linux format, the ELF format. Okay, so let's go ahead and talk a little bit more about this challenge. Let me see. Okay, we need to download Buffer Overflow 1. Alright, so this is PicoCTF 2022 Binary Overflow 1. So this challenge is an example of a RET to win binary hacking challenge. So this is kind of a category of these type of binary hacking challenges. It's called RET to win. So according to the source code, the binary contains a win function which outputs the flag file contents when it's called. So this function here is this is the one that we want to run. Fixit42 says, good night, have a great rest of the stream, and thanks for the Leetcode and Rust ideas. No worries, no worries. I don't think I give you the Leetcode, but not so much the Rust, but thank you very much for coming by, Fixit42. Let's give you a fun video redeem to see you out. How about some, I don't know, how about some Desert Frog? Okay, so we need to find some way to run this win function over here. So the binary does not call this function normally, so we need to discover a way to call it. So if you go over to your web shell, you can take a look at the code. And the code here, it includes the win function up here. So the win function says, open up the flag.txt file and read it. But if there's no file, then it's going to tell you to create a flag.txt file in this directory with your own debugging flag. So we can create the flag by the little echo command to flag.txt. How about HackerFrogs? Like and subscribe. A little bit of blatant plugging there. There you go. Okay, so if we see this message by doing our binary hacking, then we know that we've completed the challenge. Let's go ahead and talk a little bit more about this. So what we're going to do is we're going to do some stack buffer overflow. I'll explain a little bit about the concepts behind this kind of type of vulnerability. Oh, we've got ads running on Twitch. Okay, just a second, everybody. We're just going to take a little break. Let's say about 20 seconds, I need to take a little water break. And okay, we'll be back in about 20 seconds. Okay, so we're talking about stack buffer overflow. So this binary uses the unsafe gets function to save user input with a maximum buffer size of 32 bytes. So the vulnerable function over here, it defines a buff variable with a maximum size equal to buff size. And buff size is set to 32. And it runs gets. So gets is an unsafe function. It doesn't check whether or not the user input is larger than the buffer size. So you can put more than 32 bytes when you do your user input, which makes it unsafe. This means that the user input in excess of 32 bytes will result in a buffer overflow. And because buff is a regular variable, its buffer will be in the memory stack. So what is the memory stack? Let's talk about that. So the memory stack is part of the program. It's the part of program memory which stores temporary data during program execution. So we can see here that the inside of the program, it's organized into different parts. So the memory addresses over here. These are not exact memory addresses, of course. They're just meant to illustrate lower versus higher memory addresses. So in the lower memory address, you've got your program data, you've got your initialized variables, your uninitialized variables, your memory heap, and your memory stack. So what we're going to be doing in this exercise is we're going to be taking advantage of the memory stack to do stack buffer overflow. So as the memory stack grows, it progresses towards lower addresses in the program's memory. So if we were to overflow information in the stack, it would slowly start creeping up towards the lower addresses over here and overwrite these values over here. In the case of stack buffer overflow, it may be possible to overwrite memory registers. So this is another important thing we have to understand when we're talking about stack buffer overflow. It's these memory registers. So memory registers are storage locations in the CPU that hold memory addresses and data needed for program execution. So here's some example memory registers for the x86 architecture. So there's the IP memory register, the SP memory register, and the BP memory register. So these are common registers, but we only need to pay attention to one of these for this particular exercise. So there are many different memory registers in the x86 architecture, but the important one to pay attention to for this challenge is the IP instruction pointer register, which in this binary is called the EIP, since this binary is a 32-bit binary. So if the binary were a 64-bit binary, it would be called the RIP. So EIP is the specific name for 32-bit. For 64-bit, the specific name is RIP, but the general pointer is just referenced as the instruction pointer, or IP. So the EIP register contains the address of the next program instruction, and if we can override it with the stack buffer overflow, then we could execute instructions at any memory address we wanted to. Just a second, the music is a bit too much. Let's put on some different music then, something a little bit more chill. Okay, so let's continue. If we can override it with the stack buffer overflow, then we could execute instructions at any memory address that we want, and this is what we want to do. So the next step we need to do is we need to find the win function address. So it's possible to get the memory address of the win function, and our goal is to put this address in the EIP memory register so it executes the win function for us and gets the flag. So let me demonstrate a couple of ways we can do this. So we've got the vuln binary over here. We can run a program called object dump, and we can get all of the headers. So all of the headers, which are the different functions and all the other objects in the binary. And we can locate the win function right over here. So the win function is listed here, and it's at this memory address. So the memory address is in hexadecimal, but it's this value over here. And what we can do is we can remember this value, and we can feed it along with our buffer overflow in order to have this win function execute. So the other way we would get this is we can examine this with the debugger. So the debugger that we like to use is called Radare2, and we'll run it on the vuln function here. On the vuln binary, rather. Anyways, we can analyze the binary with this command inside of Radare2. This will analyze the binary for us, and then we can run the function list command. So in Radare2, AFL is going to list all the functions, all function lists we like to say. There's a lot of different functions in here, but if we go up to the top, we can see that there's a function called win down here. So simwin, and we see it's got this memory address. So this is the same memory address that we found with the object dump file, with the object dump tool, but this is just a different way of finding it. Okay, so the next thing we need to do is this. So our goal is to use stack buffer overflow to override the EIP register with the win function's memory address. So we need to figure out how many bytes we need to send to the binary before we can read before it will enter the EIP register. So the number of bytes that we need to send to the binary to reach the EIP register is called the offset, or the overflow offset value, and we can create a pattern of characters to send to the binary. So there's a special tool we can use to create a pattern of characters to feed into the user input. Okay, so let me just exit out of here for a second. So the tool that we're going to be using is another tool in the Radare2 toolset. It's called rag2. So rag2 will let you create a pattern that is of a certain size, and I think we're going to do 64 bytes. So the reason, okay, let me explain why we're doing 64 bytes. So we know that the buffer size for the user input is 32 bytes. So we don't know exactly how many bytes we need to send to overflow the buffer into the EIP, the instruction pointer. We're just going to guess, and we're going to send double the size of the buffer to see if we can locate our pattern inside of the EIP after the program crashes. So we're going to run rag to 64 bytes and render it in a form that we can read. Okay, so this is the pattern right here. This is what we're going to feed into the binary to crash the program. After the program is crashed, if we find any of these letters inside of the EIP register, then we can find out what the offset is. So just copy that. Then we're going to run Radare2 again. Okay. So let's analyze the binary just for fun. So inside of Radare2, we can run the program as normal by using the DC command. So DC runs the program. It asks us to enter the string. We'll paste in the string that we got from the rag2 program, and then we will send this to the binary. Okay, so we get signal 11, and we see that the program has crashed. So when the program crashes, we can examine what's in the memory what is in the memory registers with the dr command. So dr shows us that there's a pattern. So there's a pattern in the EIP register here, and we can just copy that. Copy that directly. You're going to see that a bunch of the different memory registers have been overwritten with the stuff that we put in the user input. So EBX has our stuff in it, EBP has our stuff in it, EIP has our stuff in it. And what we can do with the rag2 program is see what this value here that we put into the EIP equates to as far as the offset is concerned. So we see here that we've got little endian 44 characters. So little endian versus big endian. What you need to understand is that when we're feeding bytes into the memory registers or the memory addresses, they're going to be fed in from right to left instead of left to right. So normally we put stuff, we read and we write from the left-hand side of the screen to the right-hand side. But in this case, we're doing little endian order, which means we do from the right-hand side to the left-hand side. Okay, so little endian order is what we're dealing with here, so it's 44 bytes. So when the program crashes, we can see what value is in the EIP register, and then we can determine the offset. So in this case, it's going to be 44 characters. So the last thing we need to do is we need to send the payload. We can combine the offset value with the address of the win function to send a payload to the binary and get the value of the flag. Okay, so this is what we're going to do. We're just going to exit. Actually, before we do that, we're going to make note of the win function one more time. So the win function is at this address. I'm just going to copy that. I'll put it in chat just so I never forget. Ronin1 says, waiting for a string with Radare2 MCP to auto reverse or Kali NCP. I mean, that'll that might happen in the future, but it's not for the foreseeable future. Okay, so what are we going to do? What we're going to do is we're going to run a Perl command. So Perl is a pretty outdated language, but we do like to use it every once in a while to craft some payloads. So let me demonstrate. So we're just going to do Perl and execute something to create a string of characters. So we can do print the A character 44 times, because that's what we determined was the offset. So if we just run this command, it'll just print out 44 A's. What we're going to do is we're going to add on to this, and we're going to add on the address of the win function. So let's see, add on some bytes. So remember that the win function, hold on. Do I have any opinion on virtualization software, specifically VMware versus QEMU? QEMU? I only use VirtualBox. I'm afraid I don't have much of an opinion on it, unfortunately. But, what was I saying? Okay, so remember that our address for the win function is this. Unfortunately, we can't feed these hex digits directly into... You can't feed these hex digits directly into the binary, not in this order. Because the binary is using little endian architecture, or byte order rather, we have to do this backwards. So we need to take each one of these pairs, and we need to feed them in one digit at a time and backwards. So this would be 0xF6 followed by 0x91 followed by 0x04 and 0x08, like this. So we're just going to copy this. We're going to feed this in to our Perl command here. We're just going to put some slashes, some backslashes here to separate them. Okay, and what we're going to do, if we just run this command here, wait, hold on, let me take a look at my... okay. This isn't the format. Just a second. So the format is wrong. We just need to do... We need to do it like this. Okay. So the thing about this is that, you know, you'd think that it would be okay if we could just type all this stuff out, but most of these characters that we're sending, they're not ASCII. They're not characters that we can type out on a keyboard. So we need to specify that these are hexadecimal bytes by sending a command like this. So we're just going to run this command here. We're going to pipe it into the vuln binary. Okay, so we feed this command into the vuln binary, and then we get the contents of the flag. HackerFrogs, like and subscribe. Okay, so we know that this is the proper payload here. So what we're going to do is we're just going to feed this to the binary running on the server, and I just need to start that back up again. Okay, so this is the netcat command here. So we're just going to run this command. We're going to feed it into netcat like this. So Perl, and then the print command, and then the netcat command with the pipe in the middle. Please enter your string. Oh, you know what? I think I screwed up. So there's one more thing we need to send in the Perl command. We need to send the null byte to terminate the string. So we're just going to go over here and we're going to add a null byte to it. So x00, please enter your string. Hold on. What is the hex for the null byte again? Or wait, what is the byte for the carriage return or the new line? So new line hex code. Is it 0A? It's 0A, okay. Alright, so what are we doing? So on the end of this, we're just going to tack on a 0A. And okay, that was able to send the new line along with the payload, and then we get the flag. So PicoCTF addresses are easy, and then this. So the reason we needed to do that is because the binary needed us to send a new line along with the payload. So that's what we did. All right, so we can go back to the PicoCTF page, paste in the flag, and then submit the flag. All right, everybody, that was a guided walkthrough for the buffer overflow. Oh, this was a buffer overflow 1. The buffer overflow 1 challenge from PicoCTF, the PicoCTF website, from the PicoCTF 2022 event. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Barjo says 0D or 0A. Yeah, in this case it was 0A. Thank you. But yeah, sometimes you need to terminate your strings before you finish with them. We've got 17 minutes. What can we do here? I think one fun challenge we can take on if we don't have very much time is we can try out the clutter overflow challenge. Just a second. The hex was the address. The hex with the... which one? Hold on. Okay. So the payload is this, right? So we send the offset, which is 44 A's. This fills up the buffer. And then we add on something to it, and this portion is the address of the win function. So the win function is in little endian order, which means this is the backwards version of the address. And then we need to tack on a new line to the end of the string, and then send that as a payload. So yeah, Ronan, the hex was the address. Okay, I think we have some new challenges. Hold on, I just thought of this. So over at there was a new set of challenges published by PicoCTF, and it's these ones over here. So these ones are called the what is it? Pico Mini by CMU Africa. So these are a new set of challenges, and I'm very interested in trying out these challenges. So you can access it from this link over here. So in because we're doing binary stuff right now, let's go ahead and do a binary challenge from this event. Okay, this one's called Binary Injection 1, maybe? Everything else is, let's see, there's general, there's forensic, there's web stuff. How about we'll do the first one here, Binary Injection 1. And I've never seen this challenge before. We're going to see if we can solve it in the next 15 minutes. I don't know if we're going to be able to, but I guess we'll try. Okay, so a friendly program wants to greet you, but it's goodbye you might say more than it should. Can you convince it to reveal the flag? Great. Okay, let's launch the instance. Okay, so it says it should be web browser solvable, so we'll try to solve it inside the web browser. Okay, let's get out of here. Let's delete the buff1 directory. And what is the name of this challenge? It's called... Oh. It's called Input Injection 1. So let's make a directory called input. And what do we got? Oh. Wait, are these challenges bugged? Okay. Connect to the challenge instance. You can download the program file here and the source code. Great. Let's go ahead and do that. wget that thing, and then the C source code. Okay, so this is, I mean, the names of these files are all the same, but they've got different contents. So let's make the binary executable. Let's make sure that this is a proper binary. So this is a 64-bit executable. So we're dealing with a different architecture in this case. Before we were dealing with 32-bit executables, now that's 64-bit. For us, we just need to take note that the size of the memory addresses is going to be twice as big when we're dealing with these 64-bit executables. Okay, so we can run Rabin on the executable to see some more information about it. So let's see. So it shows us the architecture, the endianness, so in this case it's little endian, and it's a 64-bit ELF binary. Okay. So I'm assuming because these are easy challenges, or, well, it's categorized as a medium level challenge because there are no easy binary hacking challenges. They all require an amount of skill to finish. But anyways, let's take a look at the source code. So the big difference between most of these binary hacking challenges and reverse engineering challenges is that the reverse engineering challenges will never give you the source code, because the goal of the challenge is to determine how the binary works without the source code. But for binary hacking challenges, they usually give you the source code just so that you don't have to do a lot of reversing to complete the challenge. Okay, so we've got printf, what is your name? And then we run fgets. So fgets is a safe function. And we got string copy. Whoa. Okay, so the important thing when we're doing binary exploitation, binary hacking challenges, is to determine which vulnerable C functions are being used. Well, I mean, it doesn't need to be a C function. It's a vulnerable function inside of the programming language you're dealing with, and in this case, it's C. So void fun. Fun takes in, let's see, a name and a command. So you have some very small buffers. So there's only 10 characters allocated to these buffers. String copy, C command, string copy, buffer name. So string copy is the vulnerable function. I think this is the vulnerable function in the binary here. So the interesting thing here is nothing in the binary indicates that what is going to print out the flag. So I guess what we need to do is we just need to understand what is going to crash the program. So this just says goodbye. The main function is here. Java also uses void. Yeah, I think you'll in PicoCTF in particular, you're going to see a lot of Java compiled programs that need to be reverse engineered. So if you know Java, it's probably I've taken taken a long time to see Java. Yeah, I think in PicoCTF, if you go over to the reverse engineering challenges, there's a lot of stuff. There's a lot of Java stuff. So if you know Java, you should be able to do those challenges over there. Okay, but its goodbye might say more than it should. The goodbye says more than it should. Can you convince it to reveal the flag? So I think we're dealing with, oh gosh, what's it called? What's it called when you get a binary to what is the word? To reveal data. I think they're called I forget the name. Hold on. Binary hacking. They're like strings. They're like I can't remember the name of the thing. There was a whole set of challenges for these in another one of the PicoCTF events. Just a second. Okay, I think there was a lot of these challenges in 2024 for binary format string. That's the name of it. So it's the name of the vulnerability is called format string, and what you can do is you can take advantage of the binary to print out format strings, which can include vulnerable memory addresses, or not vulnerable memory addresses, but memory addresses of other functions. So how do we do that? It's not really something I have too much experience with. But yeah, let's see. Format string. I need to understand what's going on here. Okay, so format string vulnerability modern, maybe not modern. So we got this article from Hacking Lab. Let's take a look. Okay, so format strings and functions. So format string is a special type of string in C and C++ that is used by functions like printf to output formatted text. Okay. So numbers, in the example below, it is the first argument of the function printf. So numbers, format function is a special type of ANSI C function. Numbers something something something. The code will print numbers 1, 2, 3. Examples of functions. So there are many functions in the printf family. So printf, I'm pretty sure that there's some functions that are going to be unsafe versus safe against these type of, what are they called? Format string vulnerabilities. Okay, so we're going to get numbers, unsigned numbers, numbers in hexadecimal, strings, numbers of bytes hidden, written already. So strings, and maybe what I want to do is I want to return hexadecimal numbers, and hexadecimal numbers might be memory addresses, and the same thing with these, we might be able to get some strings. I mean, the other thing we could take a look at for these binaries in particular are strings. So these are, okay, so we've got nothing super interesting about the strings over here. Although this is a Linux command. So goodbye S, and they mentioned goodbyes in the challenge description for, what's it called? Input injection 1. But its goodbye could say more than it should. Can you convince it to reveal the flag? Reveal the flag. So go back here. Maybe we can get it to print out some strings or some other stuff. So we haven't run the function yet. What is your name? I mean, we know that the buffer is actually very small. So AAA not found. I mean, we could feed it. If it's using uname A, I'm not even sure what we should be sending it. So test, goodbye test Linux. So it runs the uname A command. So if we run it ourselves, we get the uname A. It usually gives us some information about the computer that is running. And in this case, it's just called Linux. Goodbye test Linux. Great. Well, so what would these payloads look like? Hold on. I wonder if Claude would actually tell us about this or not. Okay, we want to learn about, what is it? Format string, injection in binaries. Will you help us learn? So sometimes Claude refuses because it's like, oh, you're doing hacker stuff. I'm not allowed to teach you about hacker stuff. Okay, it occurs when the input is passed directly as a format string to functions like printf, sprintf, and fprintf, etc. Okay, so save code looks like this, and print hex from stack. Basic techniques. Panko is here. A little bit of hacker stuff is a treat. Thank you. And welcome to the stream. Everybody, did you know that Panko is a cybersecurity or infosec or hacker streamer? Let's give her a shout out. We're just doing a stray challenge right now. We don't have a lot of time to finish this. But we're taking a look at format string vulnerabilities, and we haven't really learned about this stuff yet. Shellcode, let's go. Yeah. Sorry, what were we looking at? Okay, so read stack values info leak, read memories from address arbitrary read, write to memory, direct parameters, finding offsets. So when we write format string payloads, what do example payloads look like? Specifically for beginner level challenges. But Panko, isn't it super late where you are? Read first 10 stack values, so it's just %x, or read with dots for clarity. Okay, well, let's try this. Yeah, that's what we like to send, of course. What is your name? How about this? Goodbye not found, x not found, core dumped. Okay, well, I mean that crashed the program. What happens if we send something that doesn't crash the program? Okay, well, might have slept for 24 hours straight. Are you on an insomnia like sleeping schedule right now? Please tell me you're not. Okay. Fourth dots for clarity. Example output might be something like this. Or do I need to... test payloads, AAA, and then this stuff over here. Okay. Sad to hear. Sad to hear. Well, I mean, thank you very much for being in the stream. Very much appreciated. Okay, so what are some other example payloads over here? So we got some of this stuff. Quick reference for beginners. Are they... Oh, they're giving us example stuff for pwn tools. Interesting. Correct, wrong, let's see. Common mistakes to avoid. Address is string, not bytes. Find offset first. Overwrite. Real beginner CTF examples. Read the flag. Well, I mean, leak and then write. Leak the payload. Overwrite to specific small value. Reading strings from memory. Direct access. Okay, so just read the stack values. Read as pointers. So we could try to leak out some addresses with this kind of payload here. So if we go over to, whoops, feed in a bunch of stuff and then, So if we just run the thing, it runs the uname A binary here. RoboPimp asks, do you cut your jack-o'-lanterns with round eyes or triangle eyes? Round eyes or triangle eyes? Well, triangle eyes are easier, so probably triangle eyes. Thank you, RoboPimp. Okay, let's... I mean... I don't think we're going to be able to solve this. We need to move on to the next thing. So the next thing is going to be, what is it called? Overthewire.org. We're going to be playing the Narnia game. So let's put a good number of minutes on the clock, and then we'll try this. We got up to level, I think it was level 3 in the previous session. But let me check. Okay, so we're going to be doing Over the Wire Narnia, and this is the information about the game over here. So this war game is for learning about basic, well, it's binary hacking stuff. So we were having a bit of trouble with it before because, you know, we're new to binary hacking. But let's see if we can solve a level today. Narnia, we're on level number 3. Okay, so everybody, if you want to join in along with us, these are the credentials. Okay, so let's go ahead and give our terminal some names. How about we call this one Narnia SSH? Give it a fancy color. How about red? I really like red. So we're accessing Narnia 3. And if you want to try this out yourself, this is the command you would give for SSH. Here's the password. Okay, so all of the Narnia games are in the /Narnia directory. Narnia Narnia. And what do we have here? So these are all a bunch of, they're all a bunch of SUID binaries, I'm pretty sure. Yeah. We need to find some way to take advantage of them, and then they will give us access to the next user. So we are the Narnia 3 user. We want to get access as Narnia 4 and then get their password to get to the next level. So we got a C file in here. This is what we're dealing with. So let's see, if arguments are not equal to 2, print usage file will send contents of the file 2 to dev null. Okay, so error opening in output file, input file, copied contents of something to a safer place. Okay. Well, I mean, the easiest way to understand how the binary works is to just run the binary. So this is Narnia 3. We'll send contents of file to dev null. So do we should probably, we don't have any write permissions on this directory here. So we need to create a directory to work inside of. So let's make a directory, we'll call it temp ... Narnia 3. Okay, and then we'll create a file in there. So we're going to echo HackerFrogs like and subscribe. To temp ... Narnia 3. Oh, Narnia 3 test.txt. Okay, so now that we've got a test file to work with, we can run Narnia 3 with temp ... Narnia 3 test.txt. Okay, copied contents of this to a safer place. So it copies it to dev null, which, okay, so dev null means basically throwing it into the dev null trash can. And what can we do with this? What we want to do is we want to access the password for the next level. So the password for the next level is in, what was it? Etc. Narnia pass? Yeah, so the passwords are all in this directory here. And we want to get access to the Narnia 4 password. So let's go ahead and do that. So Narnia, actually, what was it? Etc. Narnia pass, Narnia 4. Okay, so it copied the contents to a safer place, which is dev null. We need to find a way to interrupt this and either read the contents of that file or get a shell as the Narnia 4 user. Okay, so let's take a look. So it opens up the files, it copies from file 1 to file 2, but file 2 is dev null. So dev null is the is the thing that's going to be copied to. We'll send the contents of file to dev null. Error opening this file, error opening that file. Khalid Anu says, ask, did you do cybersecurity? Did you study cybersecurity? Are you talking about university? I didn't study cybersecurity in university, no. I studied cybersecurity on my own, independently. Okay, so printf. So I'm wondering if there are any really obvious flaws in the C code here. So dev null is what is it called? An absolute file path, that's fine. Does it run? So it does close, it doesn't run like the copy command or anything else like that. Printf, okay. It uses string copy. String copy is an insecure method. Narnia4 dot semicolon. Can it work? Narnia4 dot semicolon. Yeah, well, I mean, what you're thinking is that you could somehow like interrupt it and send it to like something else, like yeah, cat path Narnia 4, cat path Narnia 4. We could make so. According to the code, copy from file 1 to file 2, read, write. I think it could be that one of these functions can be interrupted. Close the files here, exit. Printf copied contents to a safer place. Khalid asks, what did you study in university? I studied illustration in university. I went to an art school. So I'm not doing anything related to cybersecurity or even technology when I was studying you mean like race? I mean, is this a race condition? I don't think this is a race condition. Okay, let's grab this code and let's see if Claude can identify what's going on here. What is vulnerable in this C code? Panico asks, HackerFrogs merch when? When I become a bigger channel. I don't think it's really worth it to create merch right now. But thank you very much. You know what I was thinking? Creating like a HackerFrogs hat would be really fun, because it's just like an orange ball cap. I can put a logo on it or something, so I can have a shy hat. What are we doing? I will take the whole supply of skateboarding frog shirts. Thank you. Thank you. Thank you, Panko. Okay, this doesn't seem to want to go. Let me try reloading the page. Why Claude? First time seeing this one. Claude is supposed to be really good at doing coding stuff, but I've got, I also have ChatGPT here if I wanted to use that. Good to see you, Cyrus. My name isn't Cyrus. Oh, it's thinking. It might redact this, because sometimes when ChatGPT gives out hacking advice, it realizes that it shouldn't be giving us hacking advice, and then it redacts everything. Okay, so string copy copies an unbound string into ifile32 if the argument is less than or equal to 32 bytes. It overflows ifile on the stack for a potential control flow hijack. Control flow hijack, you say? Other sloppy, dangerous bits, not strictly overflow but still bugs. Buff is not null terminated. Treated as a single, it's a C string later, that'd be unsafe. How to harden. How to harden. Open let dev null with, let's see, configure defensive flags. A classic stack-based overflow. Stack-based overflow. So string copy. So what would we, how would we, a hat would be nice. maybe one day. Okay, so Claude also says that this is a classic buffer overflow vulnerability, which can be, we can redirect where the file contents are written. Okay, so unchecked string copy on the line here. String copy ifile arg1 no length check. So string copy copies until it finds a null byte with no bounds checking. If argument 1 is longer than 32 bytes, it overflows the ifile buffer. Look for a bypass prompt and get it in the GPT settings. Bypass prompt, are we talking about, we're trying to get around filters? Okay, so key observation, O file is declared after I file in the code, which typically means that it is at a higher address on the stack. When you overflow I file, you can overwrite O file. So goal is to change the output file from dev null to somewhere that we can control. Change the output file from dev null to somewhere we can control. Okay, if this is the goal, then we can start taking a look at this inside of, it won't block you for pen tests. Are you talking about bypass prompt? Are there well documented prompts for this kind of stuff? Okay, so let's try doing some Radare 2, Narnia 3, and let's analyze this thing. Okay, so after we analyze this, let's take a look at the main function. So PDF at main. And what we need to do is we need to figure out where dev null is saved into here. So dev null is saved into var 18 hex and var 14 hex. So we need to figure out if we can overwrite these. Okay, so dev null. Yeah, let's take a look at these variables. So AFV. Okay, let's what was that first one? So that one address for dev null, we want to replace dev null with something else. var 14 dev null. So null is here, dev is here. Copy that. We want to take a look at px print hexadecimal at this is this 64? This is probably 16-bit. So EBP minus 18 hex. Okay, so right now there's nothing in there. Masterism says redirect 32 bytes into temptest2.txt. Yeah, I just need to. So we need to feed it. We need to feed it like a file name, right? Because if you don't feed it a file name, then it doesn't work. Okay, so let's run the binary. Okay, so we need to run this with a specific argument. Hold on, everybody. I've got ads running on Twitch, so I'll run them on YouTube as well. And we'll put on the birds. How about these birds? Okay, so this is a lovely northern flicker woodpecker. I'll be back in about 50 seconds. Enjoy the music and enjoy the birds. Agent 57 says, can I guide the raid? You can give a suggestion, sure. Why not? If I don't like it, I don't need to follow it, but feel free. Can we zoom in on these things? Hold on. J Beers 11 would be my suggestion. Yeah, no worries, no worries. We're not going to be ending for quite a while, at least like an hour or so. Or let's see, what time is it right now? Maybe like 2 hours. It might be a while. Anyways. But let me know a little bit closer to the stream ending time. Thank you. Thank you, Agent 57. Okay, so it'll send contents to dev null. We need to find out how to run Redare2 with arguments. Okay, so Redare2 binary arguments. Cheat sheet, R2 wiki, read the docs, cheat sheet. Okay. So Redare2 is our favorite debugger, but there's all sorts of stuff we don't know how to do with it yet. Okay, argument. To pass arguments. Okay, so R2 D run2 program pwn1 argument 1 to pass standard in commands. Okay. So we need to run2 program equals bin ls. He's doing OSCP prep, and you might like what he's doing. No worries, no worries. Let me, is this person in the InfoSec streams list? Peace out, you're awesome. No worries, Agent 57. Thank you very much for letting me know. So let me see if they're on InfoSec streams. They are on InfoSec streams. Awesome. Okay, so
Hack the planet! Hack the planet! Shut up and get in.
Thank you very much for the Hack the Planet, Agent 57. Thank you. Okay, so we need to run like run. start R2 in debugger mode. R2 will fork and attach to pass arguments. Run2 program equals something. Do we need to make? Hold on. Let me exit from here first. Run2 help. So no program system or run lib rule defined, cannot set up the environment. So can we then like a man page on that? Okay, so this is a launcher for executing programs with custom environments, arguments, permissions, working directories, and redirected file descriptions. Okay. So, I mean, I guess, so sample run2 script cat run2 program equals this, arguments equal this, program equals this, arguments equals this, standard in. Okay, so we can set a bunch of stuff like that. So this is a sample run2 script. Okay, let me start copying here so that we can use it later. Okay, we have a directory that we're using right now. It's, let's see, nano R2 script. Is that the name? Does it want to have? Ah, okay. So the name of the program could be anything. R2 script, and we're going to put it in the directory that we own. So temp ... Narnia 3. Okay. So we need to define the program, and then we need to define the arguments. So the program is going to be /Narnia /Narnia 3, and the arguments for arg0, we'll feed it temp ... Narnia 3 / test.txt. Okay, so let's save that out. First, I need to verify where the run2 program is. User local bin run2. So we need to modify our environment with our script like this. Okay, so after this, we need to start modifying the test file. So the test file is in temp ... Narnia 3 test.txt. HackerFrogs like and subscribe. Okay, so we're gonna fill this with the pattern. So we need to take a look at what the buffer is for the file size. Actually, wait. The AI should have been able to identify what the buffer size is, right? So ifile, yeah, it's 32 bytes. So no length check. It does string copy. This is a vulnerable C function. Greater than 32 bytes. Masters, and thank you. Thank you very much for letting me know. I think greater than 32 bytes. Previously I did like 64 bytes. We'll feed we'll see. We'll feed 64 bytes into the test.txt. So let's see. What was it? The program we wanted was rag2. We'll feed 64 bytes into so this gets us a pattern. So this pattern we can redirect into temp ... Narnia3 test.txt. If the AI is correct. Well, I mean, the AI was using the information from this C file here. And we got ifile32. So ifile32, buff32. We should be able to do buffer overflow with more than 32 bytes. So I'll do 64, and we'll see what happens. What happens with the thing? Okay, so we're gonna run R2, and how do you run it? R2D rarun2 program equals something. Program equals temp Narnia, Narnia 3 R2 script. Okay, so I guess it's running. Okay, and then we let's run the program. Processed exited. Okay, so it exited. It's not what we want. Okay, so let's take a look at the main function again. Oh, you know what? I don't think I'm looking at... I don't... Radar 2 opened in read-write mode. Are we... No. I'm not using the program properly. Hold on. To pass arguments, R2D rarun2 program equals something something. Argument equals this. To pass standard in. Okay, so let's just ask over here. Okay, I want to run Radari2 on a binary, but pass in command arguments to the debugging binary. How do we do this? So I just want to know how to use the rarun2 program. Or did I spell rarun2 incorrectly or something? It's always about the syntax errors and the spelling errors. It's searching the web. Isn't that novel? Okay, so there are three common ways. From the shell, when you start R2, okay, so... okay. So it'll spawn the debug process with those arg values. So I guess we don't need to do anything super fancy. We don't need to use raw run. We just need to run the program with the arguments on the command line. So, okay, let's do it that way. That's the easiest way. So R2 slash Narnia Narnia 3, and we'll feed it temp ... Narnia 3 test.txt. Oh, we need to run it in debug mode. Okay. Okay, this seems good, so let's go ahead and run the program. Process exited. So it copied the contents to a safer place, dev null. Process exited. So obviously we didn't send enough bytes to crash the program. But let's see what actually happens. Okay, so let's reset the program. And then we'll set a breakpoint. So PDF at main. So copy the contents to a safer place. Let's go ahead and set a breakpoint right here. So db this, and then run the program. Oh. The second time it ran the program, it didn't take in the arguments. Okay, well, From the shell, when you start R2, if you've already opened the file in R2, use the OOD and DOO commands to open it in debug mode with the arguments. DOO using alias, reopen in debugger mode and pass arguments. Oh, so you can do OOD and then pass in arguments. Alright. Let's do that. OOD, pass in the arguments. So, etc. No, temp. Narnia 3 test.txt. Okay, and then execute the program. Hit the breakpoint. Okay, great. And now we can take a look at the contents of the memory. So we want to take a look at the variables. So we know that that dev null, which is the thing that we want to overwrite, is at these locations right here. So 18H and let's see. So get the hexadecimal at this thing. Base pointer minus hex 18H. Okay, so we got dev null here, but the thing is we don't see any of our other input here. So do we need to feed more characters into our file? So let's find out where the file contents were put. So read write. So it loads in this stuff to write. So var4h and var58h. So we can take a look at var58h and maybe we can see if our stuff is in there. Feed it all the feed it all the characters. px at this thing. ebp minus. Okay, so actually we got pretty close. No, wait, we didn't get pretty close. So dev null, let's see. I think we need to send another 1, 2, 3, 3 rows. Okay, no, it's more than that. 1, 1, 2, and these are 16 character. These are 16 character addresses. So this is 32. So this is 32 plus 1. 32 plus 1, 33 plus 1, 2, 3, 4, 5, 6, 7, 8, 9. 33 plus 9. 33 plus 9 is 42. 42 plus 64. 64 plus 42. Oh man, math is not my strong suit. Okay. 64 equals, that's 100, that is 8, 108, 108. 86. So we've already created 64. So we need to put another 44 characters in there. And that should be 108. So if it's 108, we can create a pattern with reg2 to create this. Just more math, no worries. This is why we have computers. Computers do the math for us. Okay. So let's go back. Exit out of here. And so echo all this into temp ... Narnia 3. Test.txt. Okay, so let's cat that out just to make sure that the stuff got in there. Okay, looks good. Let's go back in. Okay, then set the breakpoint. But first, let's take a look here. So copied your contents to a safer place. Sure. Let's set our breakpoint here. Then let's run the program. Hit breakpoint. Okay. So we hit the breakpoint. Let's take a look at the dev null thing. So the dev null thing is where? Here. Okay. So 18H. Let's take a look. So all of these variables are behind the base pointer. So EBP in this case. And that's still dev null. Okay, if that's still dev null, let's take a look at the other variable. So the other variable is this. Okay, I think I see the problem here. So the it could be that the stack is growing this way and not this way, which means that we wouldn't be able to overwrite the dev null. But you know, because is this the back of our input? No, that's not the back of our input. Where is it? So this goes until capital J and then capital K. Okay, so this is it. This is the stuff that ends up in the memory here. Use the first one in custom instructions in ChatGPT personalization settings. Thank you very much. Let me take a look. Let me take a look. I'll take a look after the stream, but I'll save it to another web browser window. Thanks. Okay, so I mean, I wonder if it's even possible to do this through the file contents here. Actually, wait. Is it the name? Is it the name of the file itself that we have to overflow? Maybe. Okay, let's try like a really long file name. Okay, so if it's a really long file name, we need to send how many more? 2, 3, 4, 5, 6, 7, 8. So that's half. So that's another 8 characters. 8 characters. 9, 10, 11, 12, 13, 14, 15, 16, 17. So we need 17 more characters on this file name. Why not command injection? So in this, I mean, we could find some way to do command injection, but the easier way to do it is to overwrite dev null and replace dev null with another file that we control, and that way we can get the password, because the binary itself copies the contents of files to other files. So So if we could, I mean, the thing here is that we would normally be sending it. We would normally be sending it the absolute file path of the password file. So the absolute path of the password file in this case is like /Narnia /etc /Narnia _ pass /Narnia 4. Narnia 4. But this isn't long enough. I mean, I guess we could. Let's echo this out. So echo this out and pipe that into word count. So this is 25 characters here. So I mean, it's actually 24 because this is 24 characters. So how many characters is the stuff that we have right now? The stuff we have right now is, this is 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, this is the same amount of, so what would we need to do? So we would do like a .. to prepend the thing. So that's .. and then fill this with something that we control. How do we pull this off? Okay, so that's how many .. slashes? 1, 2, 3, 4. Well, that's only 3. Hold on. Okay. So something like this. .. .. We can word count this. .33 characters. So I got it wrong. I thought it was the contents that needed to be that need to be buffer overflowed, but it actually turns out it's the name of the file that needs to be buffer overflowed. Let's do an experiment. Okay, so let's OOD or we do OOD with the argument. Okay. So, and then we DB or DC to run the program. Error opening. Error opening. So it couldn't open the file. Okay. Let's take a look at what's in this memory address. EBP minus hex 58. There's nothing here. And what about the other one, which was hex 18? There's nothing here as well. Okay, so it's because it didn't actually run. Okay, so let's do our experiment. If we want to do the experiment, we need to make a long file name. So the long file name, we need to create that. With the file with the long name, we need to create that. Okay, there's an ad running on Twitch right now. Just a second. Okay, we'll be back in about 20 seconds. Just need to have a little water break. But in the meantime, enjoy the sparrows. Okay, so let's create that really long file. Echo random into temp Narnia 3 slash long file name 123456789.txt. Okay, so this exists now, so let's go ahead and feed this into Radare. Okay, and then we will do the same thing. We'll see if it actually buffer overflows. And PDF at main. We'll set our breakpoint over here. Or let's see, DB for breakpoint. Then run the program. Error opening. Error opening the TXT file. Okay, let's take a look. Error opening. I mean that probably means that all the variables have been erased. Yeah, so the variables have been erased in this case. So that's probably because the thing is too long. So error opening this thing. So this is error opening this, which means that it's that this actually got into the buffer. So we need what do we need to do in this case? We need to replace this with something that we control. So we control okay, so let's go back. First of all, I need to get the name of the file that we used. The name of the file we used was this. Okay, and we know that this part got into the buffer. This part overflowed into the buffer, so we need to create something like this. And we'll do temp ... Narnia 3 and test.txt, because we already have this. Okay, and so if this works, then we should get some new contents into here. The thing is that this is wait, can this be completely fictional? Yeah, I think it could be that we don't need a legitimate file name for this. Hold on. So OD this. Okay, and then run the thing. Error opening. Error opening temp Narnia. Error opening temp Narnia long file name something something. Okay, so I guess it does need to exist. How about we do it like this? We'll put it between some quotes. Error opening, okay. So the Let's run it one more time. We'll set another breakpoint. So the other breakpoint we'll set is going to be right after this thing is set, dev null. Error opening happens here. So we should probably set up a breakpoint before that. So error opening. Let's set up a breakpoint here. Hit the breakpoint. Okay. So the breakpoint's been hit. Let's take a look at the contents of those important memory registers. Okay, so we've overridden it. And Obito Uchiha, hello, nice to see you here. Welcome to the stream. We're just trying to do some binary hacking over here. So it's like 58. Okay, so we managed to completely overwrite this, but it only takes in a small part here. So Ronan, I think Ronan asked about why we weren't doing like command injection. Maybe we should be aiming at command injection in this case. But let's go back to the AI, and I didn't read everything that the AI wrote for us here. So on the unchecked string copy line, okay. Change output from dev null to something we control. Okay? So it's not possible. It's not possible. Normal execution, vulnerable, etc. password. Contents copied to dev null, lost forever. Okay? Now the file contents are in temp stolen instead. Shows the contents of the input file. The problem is the input file isn't anything meaningful in this case. Potential buffer overflow in read, less severe. Okay. Overwrite return address. Read sensitive files and redirect output. So payload equals etc. shadow and then a bunch of stuff. Etc. shadow and then a bunch of stuff, and then the payload is going to be this. Execute with root privileges if the binary is SUID. Why dev null is ironic. Okay. So I mean, here's the problem. We want to make this the file that we want to copy, and we want to make this the password file. Edwin Seb says, binary hacking again? Yep, binary hacking as usual. So we want to make it etc. Narnia pass Narnia 4, and then a bunch of stuff, and then the directory that we control. So what was it? Temp Narnia 3 test.txt. But how do we nullify this? How do we just put a bunch of A's in here? Is this going to work? And how much input did we send? Okay, so this is where we want to put the password file. So this is exactly, this is like 16. This is 32. This is 32. This is 32, but what we want to send over here, this is like 25. So 25 26, 27, 28, 29, 30, 31, 32. And then we want to include the file name that we own over here. I don't know if this is this might be too long, because we've only got like 16 We've only got 16 to work with. Hold on. This part over here, this is only 16. Oh wait. So everything after this got cut off. So this name has to Narnia 3 test. Narnia 3 test. We can create that. Cernivas? I'm not too sure how to pronounce that, but hello, nice to see you here. Let us know how to pronounce that, thank you. Okay, so this is just a test file. Right? I mean, we can just call this like a.txt. Not even a.txt. I mean, we can just call it test. Let's give that a go. Actually, before we exit, I want to get the exact length of this thing. So we'll know what the offset is. This is 56 characters. So I mean, it's 56 characters, but this part gets cut off. So this is actually 52 characters. So we need to craft a payload that is exactly 52 characters. What was it? Temp, etc. Narnia Pass. Narnia 4. And then a bunch of garbage. And this is 52 characters as well. Let's try this payload. All right, so we need to get out of here. We need to create the file. Okay, and then we need to go back in and give this exact payload. Where is it? Here. This one. Okay, and then run the thing and see if it works. Error opening. Okay, so it errored out trying to open this file. The problem is that the payload can't open this file because the file's got a bunch of weird stuff in it. How do we get past this? Okay, let's try asking for some help. Okay, so Masterism said, did you try to run it with 33 or more A's and then sending them to a text file instead of just the 8 or so that you did in the beginning? I mean, the contents of the TXT file, I mean, I guess that is another thing that we could pay attention to. Because the contents of the TXT file get put in here. The problem is that I mean, I guess this could be, the contents of the TXT file could potentially overwrite like stuff like the EIP. Okay, let's take a look at the source code one more time. Okay, character I file, out file. So in file is 32, out file is 16. This is dev null right here, and I'm pretty sure dev null. Yeah. Okay, and then the I file, and then buff 32. So buff is, where is it referenced? So read size of buff -1. So copy from file 1 to file 2. So I'm pretty sure we can't overwrite. Well, I mean, I can't find a way to overwrite the send location, but we might be able to just do a general buffer overflow that overwrites the EIP by writing something really big into the file. Let's give this a try. Okay, so echo out something really, we need a really big pattern. So the really big pattern, rag to, let's do 255, just for fun. Okay, so we have our big output. Let's echo it out to the thing we own, temp ... Narnia 3 big file.txt. Okay, so we got all this stuff in here. Let's see if we can feed this to... Hanky says, hi, what are we doing now? We're still doing Narnia level 3. We're still doing Narnia level 3. Okay, so we have the big file here. If we just try catting it out, then it's like this. Sure. Let's run Radare. Narnia 3. Okay, then run the file. Does it process exited? Okay, so process exited. That means that the file wasn't big enough. It wasn't big enough. It didn't crash the thing. I suppose the only thing we could do now is we just create a ridiculously large file then. Let's try like 1,000 bytes. Or 25,000 bytes. So here's a really big file. Temp Narnia 3 big file. Okay, and then run the thing again. Okay, so I don't think the size of the file really makes that much of a difference here. So the AI identifies here that the main vulnerability is a stack buffer overflow via string copy that allows you to control where the file contents are written by overriding the O file variable. So let's try asking a question to the AI, our good friend, the AI. Size of the name of the file. Yeah, the size of the name of the file is important here. We want to read the first file before the a character offset, or a character portion of this string. How can we craft payload that will not be, that will not cause an error? May I look at the source code? Yeah, sure. So here's the, I'll give you an SSH command you can use to get into the server. SSH Narnia3 at narnia.labs.overthewire.org. Can't remember what the actual command is. Here, let me get the command. So you can log in over there. The password is what? This is the password. The password, the source file is in narnia3.c. Okay, the issue is that the string copy will copy everything including the A's, making an invalid file. Where are we? This will make an invalid file for iFile. Okay, the solution, use a null byte to terminate early. So you need to terminate the string right after this using a null byte so that the string copy stops there for iFile, but the overflow continues to overwrite OFile. So I mean, I don't know if we can do this. I don't know if we can do this manually. Command line version would be this. So Narnia 3, Python 3, something something. Oh, okay. Does this work? I mean, I suppose we could do the same thing in Perl. Then read the result. Detailed calculation. So input file is this. Okay. I mean, I'd prefer not to have to run like a pwn tool script if I don't need to. But what do we got? I think so. We were talking about making payloads like this using Perl. So if we're using Perl to do this, it would be something like this. So print out this. Print out this, and then add on a bunch, and then add a null byte. So the null byte is x00. Can put that between some quotes. And then we would have to add Narnia test. Temp Narnia test over here. And we'll pipe this into word count. Man, when did life get so complicated? That's 45 characters. Okay, so if that's 45 characters, we need to add another 7. So we'll add A times 7. That's 52. Okay, so what we want to do is we want to put in this as our payload. Man, it feels like we've been working on this forever. Anyways, let's grab this. Let's go back and let's see, OOD, this thing. Invalid subcommand, try P, process finished. Okay, let's... Alright, so... Oh, this is still word count. Okay, never mind. That was silly. Okay, we got. Let's run this thing. Warning: command substitution ignored null byte in input. Command substitution ignored null byte in input. Error opening temp Narnia 3 test. So I mean, it ignored. Okay, so I mean, I'm trying to do this as a one-liner, but when I'm doing this as a one-liner, the null byte gets us in trouble. Okay, so let's grab this. We'll let it know that we're having some trouble. Okay, this is my payload, but I get an error, a bash error. Ronan says, by overwriting I file beyond 32 bytes, you overwrite O file with a path that you control. I mean, I would like to. You need 32 bytes before the file path. Yeah, I mean, the thing is that we need to provide the file we actually want to read. And the file we want to read is the password file. Okay, so what does it suggest here? Okay, the issue is that bash strips null bytes from command substitutions. You need to pass the payload differently. Okay, use the file most reliable. Okay, so R2 Narnia 3 temp payload, or pass an argument via run 2. So the payload is, I mean, we would run the payload and then redirect it into a file, right? Use a run 2 profile. Set args inside of Radare 2. Okay. Use Python to execute. Use process substitution workaround. Okay, so Henke says, I see the code in the vulners for 40 bytes and can override the 16 byte for the out file path. You need to be careful for the name and the parameter. Need the correct path source. Okay, so let's see. So we can't run the payload, and the payload is this one. we want to run this, but there's a null byte in here. I guess we could write this to a file, right? That's what, hold on, my music stopped. Let's put the music on somewhere else. How about this music? Okay, so we'll run this command. We'll output this to a file. So echo, or just run this thing, output it to temp Narnia 3 payload.txt. Okay, warning, command substitution ignored null byte and input. Okay, so so Henke says the idea is to use string copy to override the O file using the buffer needing yeah. So it's 50, it's like 52 bytes total for the payload. Yeah, so the payload should be 52 bytes. So actually we don't need command substitution in this case. Yeah, it's because we're doing command substitution. That's why we're getting the error message. But we can just run this normally. And if we take a look at the contents of temp Narnia 3 payload.txt, xxd. Wait, there's no xdd. Okay. Everybody, you need to spell properly. Okay, so the null byte is in here. Great. And I guess I can also get the length of the contents. 27. 27? No. Let's cat that. 52. Okay. So let's do Radare 2, where is it? And what was the command? I? Set args inside of Radare 2, or use a rawrun2 profile, or use a file. So use a file, or pass an argument via rawrun. So it says you're supposed to use -i. Let's see if -i works. Payload.txt. Usage Narnia 3 file will send contents of file to dev null. Process exited with status whatever. Okay, so it didn't take this in as the command argument. Was that how we were supposed to do it? Yeah. Okay, so use it with Radare something. Use a rawrun2 profile. set args inside of Radari2. Use Python to execute it. I mean, we might have to use Python to execute it at this point, because the can you use 2.0 to fill the payload rather than 0.0? What is 0? Like 2.0 is hex 2.0 is that space? ASCII x 2.0. That's a space character. Yeah, I don't think space works for this case. I mean, maybe we could try like new line. New line is hex 0A. Let's ask a question or two. For CTFs, I recommend just running the thing directly to verify that works, then debug if needed. Run it directly first. This is a heck of a Python one-liner. Jeez. But what does this thing do? Okay, so it's etc Narnia pass this thing, import sys, yeah, this is wild. Okay, so here's another question. Can we pass command line arguments from a file? Panko, hello, nice to see you here. You're still awake. That's wonderful. How much more time do we have? We've got 50 minutes. I can do another 15 minutes before I have to go get dinner. Getting pretty hungry, but you know, gotta do what you gotta do. Panko, hello, nice to see you. Do you want to try this out? You're in the pearl trenches. Yeah, I guess you could say that. We're just trying to find a payload that's going to work for this binary hacking exercise. Okay, so here's a question. Can we provide a file or provide the contents of a file as a command line argument? In Linux. Okay, it's possible to provide the contents of the file as command argument in Linux using various methods. Tell me more. Command substitution. This is the most common and versatile method. You can use $cat file name, or we can use $cat file name. Huh. I mean, that would be pretty cool. Because we're having a problem. We're having a problem. Okay, let's exit out of here. So we want to run Narnia 3 cat file name. So we're gonna provide cat temp ... Narnia 3 payload.txt. But it says, warning, command substitution ignored null byte in input. So it didn't work. So we can't use command substitution. What's another thing we could do? So command substitution, backticks, older method. Similar to command substitution, backticks also execute a command and substitute its input. So command name and then surround it with the quotes and backticks. You want the solution or part of it? Well, I mean, I'd like to know if I'm on the right track. Ronin 1, have you solved this thing already? So I mean, I'm pretty sure that I'm on the right path. Okay, so it still says command substitution ignored null byte in input. Okay. Zargs for multiple arguments or specific formatting. If you need to process each line, cat file name zargs command name. So cat file name zargs command name. Let's try this. Cat this. Zargs Narnia 3. Warning, a null character appeared in the input. It cannot be passed through in the argument list. Did you mean to use the dash null option? It cannot be passed through in the argument list. Can we do dash null? Will that let us through? Doesn't work. Let's just try. Let's try it without the zargs. Let's just usage Narnia 3 file will send contents of the file to dev null. Okay. So if we just run. If we just run the payload, it doesn't really work. 52 characters. I just want to make sure that there's the null byte in here. Pretty sure there is. Yeah, there it is. What other process substitution for commands expecting a file path? Quoting, also use double quotes around command substitutions. Command behavior, file size. But Ronin, please give me a hint. If you have a hint, please give me a hint. Comrade Saul, hello, nice to see you here. Welcome to the stream. We're just hitting our heads against the wall over here. I mean, I suppose we could write. I guess the last thing we could do is we could try writing like a pwn tools file. So the pwn tools file, the pwn tools like script is this one. So from pwn import whatever payload. Okay, let's give this a try. Temp Narnia 3 n3.py. Okay, build the payload. Payload equals bytes, etc. Narnia past Narnia 4. This is what we want. And then add the null byte, and then add the 7, and then add temp ... Narnia 3 test. Run the process not through bash process or for debugging with GDB. Create a folder that will be, create a folder that is a 32 character path. Create a folder that's a 32 character path. Okay, so let me get out of here. We'll save this just in case we need to come back to it later. So create a folder that's a 32 character path. Yeah, so we got etc. Narnia pass Narnia. Create a folder that's a 32 character path. But if we provide a folder that's a 32 character path, then I mean the temporary directory we have right now is like this. And that's not too many characters. That's only 16 characters. So if we wanted to create a 32 character path that's just the folder, then it would be (32 characters). We need another 16 characters here. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. That's 32. Wow, I just eyeballed that too. Okay, so we have to make a directory that's like this, and that creates a 32 character path. Actually, that's not exactly 32, that's 31. Because we need to, yeah, so that's just 31. We need an P in here as well. Okay, create this directory in here. Make directory temp. Narnia 3. The rest of this. So this is a 32 character path. Echo dot dot word count, that's 33. But without the new line, it's 32. So if we what does this achieve? So we know that part of the payload has to be a directory here. So what do we do after this? So the folder is a 32 character path, and then AI gave me the solution. I mean, Ronan, you can do this yourself if you've got like an SSH connection. So the 32 character path is here, and then the file that we actually want to read is etc. Narnia pass Narnia 4. You're in bed. Okay. That will fill the payload for I file, add destination for the next overflow of the O file. So the O file, this fills up the I file. The problem is that the I file needs to be the password file, doesn't it? Put the Narnia 4 as part of the path. Okay, so etc. Narnia 4 pass Narnia 4. Okay, so Ronan says put Narnia 4 after the path. But if we put this after the path, okay, I just want to see how large the payload is here. Somehow, somehow. 57. So that's 57. The payload should be a maximum of 52. So, I mean, we might be able to get this done if we sit in 56 max. 56 max. Oh. Okay. Narnia 3. Do some command substitution in here. Oh boy. Syntax error near unexpected token echo. Unexpected oh, okay. We need to do this, the $sign, when we use command substitution. Error opening, okay. Error opening this thing, let's see. So it's trying to open up etc. Narnia pass. Error opening etc. Narnia pass Narnia 4. Okay, so I mean this, we might be able to get it done if we're sitting inside of the Narnia directory, the Narnia pass directory, because that gives us a few more characters to work with. What do you mean, no such? Oh, it's in the etc. Narnia pass directory. Yeah. Okay, so this gives us a few more characters to work with. So now, okay, so we run /Narnia, Narnia 3. We echo out this thing. But now we just need to do current directory Narnia 4. Error opening Narnia 4. Hold on. Narnia 4 is in here. Okay, so Ronan says you have the folder in the path that fills in 32 bytes. Now you need the Narnia 4 after without the copy. So, you need Narnia 4 after, okay? I mean, if we feed it this, it gives us an error message, error opening dot slash Narnia 4. But it should be able to read. I mean, maybe it can't read this because it doesn't know, it's not really looking for the relative file path. It's looking for an absolute file path. Don't use echo. Don't use echo. Error opening Narnia 4. Just get in the folder. Yeah. I mean, we're in the folder. We're in the Narnia Pass folder right now. Okay, so what do we do here? So it's here. It's here. We want to do... Let's try etc. Narnia Pass. Narnia 4. Okay, so this didn't work because we sent too many characters. How many characters are we off by? 1, 2, 3, 4. 4 characters. So do we sit in... The 32 bytes folder, get the Narnia 4 there. So we're supposed to put Narnia 4 in here. So Narnia 4 takes up how many bytes? 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7, 8. So create a directory that looks like this. Man. Okay. You know what? I think I do want to see this inside of the debugger so that I can understand what is actually getting filled up. So let's run, I guess we're running the same thing. Except we're running it with redirect 2. Okay, so let's set up a breakpoint. So the error opening part is over here. Let's set up breakpoint here. Okay, so error opening. What is this part? Error opening this. Didn't we set up our breakpoint? How can you have a file in the other folder without copy? How can you have a file in the other folder without copy? You know, Ronan, I'm running out of problem-solving juice. It's been a long night. Sorry, I'm sure you have the solution, but it's the time. Yeah, it's let me think about this. Okay, when we ran... So this is the 32... Time to start sipping on the silly juice. 5+ hours. Yeah, I've been at this for a while. Okay, so I appreciate everybody's input, and I'm just trying to make use of it. Okay, so we'll copy this. Run this again. We just need to find a breakpoint before the error messages start running. So error opening this. Great. So, I mean, I thought we could just set a breakpoint before this stuff runs. The error opening. Error opening this as well. Okay. Let's set a breakpoint here. Yeah. Okay. So breakpoint here. Run the program. Hit the breakpoint. Now let's take a look at the memory contents. So px at ebp minus hex 18. So hex 18 has been replaced. Hex 18 has been replaced. This is where the dev null stuff was before, but now it's got etc Narnia pass Narnia 4. So I think the error message is cannot open Narnia 4. If we take a look at the other variable, so it's hex 58, it's this thing right here. So temp Narnia 3 and then this big thing to fill up the memory address. So we got etc Narnia pass here, Narnia 4. I see the error is permission denied. You need to create some symbolic link to the password. The error is permission denied. Really? Is it? Okay, when we just run the thing, it says error opening etc Narnia pass Narnia something something. So we've got etc Narnia pass Narnia something something. This is too long because it has to be a maximum of, what was it, 16? That's 16, maximum of 16 bytes. So this was okay. I mean, this, I don't know if it's actually okay. So the other thing that we could do is we could just try opening up Narnia 4, etc Narnia 4, etc Narnia pass. Narnia 4. And how would that fill up this thing? So etc Narnia underscore pass. Let me think about this. Echo out. Oh, I've got it up here. How many characters is this? "24 characters. But what if we do a bunch of these? Then it's 35. We need it to be 32. This is 32. but I don't know if it'll accept this. I mean, I wonder if this is legitimate or not. I don't know. Okay, let's try this again. Get out of here. Exit. Actually, no, we don't need to exit. We need to... OOD, and then fill it with this. Okay, and then run the thing. Hit the breakpoint, okay. Take a look at the contents. So the contents are still here, etc. Narnia, Narnia Pass, Narnia 4. DevNull is still here, but it's been overwritten a little bit. So I'm pretty sure this isn't going to... Error opening. Okay. So it had an error opening because I think the output is one character too long. So if that's the case, then we could do this instead. Okay, and then run the thing. Take a look at the contents. Yeah, so current directory, backup directory, etc. Narnia, Narnia Pass 4. We still have DevNull here, but when we run the thing, it's just going to run normally. It still has an error opening this. Oh, is it because we don't have permissions for this directory or for this file? Hold on. Hit breakpoint. Error opening. Yeah, Henke's correct. Henke's correct because I can't read this file. I mean, we should be able to read the file, but for some reason it doesn't work because... Okay, so these are the password files. So the password files are owned by Narnia 4. But this binary should be able to run, it should be able to read Narnia 4 files. It should be able to run the Narnia 4 file because it's owned by Narnia 4 and it's an SUID binary. Okay, so Henke said you need to create a symbolic link to the password. Create a symbolic link to the password. Okay. I mean, if we need to create a symbolic link to the password, then how do we do it? So we control the etc. No, the temp ... Narnia 3 directory. Okay, and we got all this stuff in here. We also have this directory right here that will completely fill up the thing. So link, yeah, make a symbolic link. So the link is the name. Is it the name first or the link file first? I forget. Linux symbolic link command. Okay, so LNS, path to original file or directory, path to new symlink. Okay, so let's make that link. So the original thing that we want to link is etc. Narnia pass Narnia 4. And we want to make the link in Narnia 3. We want to make something that's the same length as this directory. The same length as this directory. Maybe like this. That's pretty messy looking. Oh well. Okay, so now we just need to move into our current directory, or we need to move into the directory that we own. So temp Narnia pass Narnia 3. Okay. So the full file path that we want to provide is this. When we run Radare 2. So it's this, but we also need to provide a new directory to write to. So the directory that we want to write to is going to be like temp Narnia 3 /a. I don't know how many characters this is. It has to be 52 characters exactly. This is 50 characters. Okay, this is 49 characters. So we need to make it ABC. To make it 51 characters, or ABCD for 52 characters. This is 52 characters. Let's create these files. So the file is going to be... Actually, do we need to create the file? Or will it create the file for us? I don't even know. But I'll create the file, you know, just cause. Test. Not a directory. Not a directory? What? Test. Temp. Narnia 3. Oh, no. We need to create this. Okay, and we will create one for this, and we'll create one for this. Man, I hope I can pull this off before before I run out of time, because I've been working at this for hours. Okay. So we made our symbolic link already. So this is our payload. I mean, it should be like ABC or ABCD. We'll find out which one it is in just a bit. Okay. Okay, I think we're getting I think we're getting close. Oh boy. Narnia 3. Okay, let's give this a try. Error opening. Error opening this thing. Oh. Okay, so what happened here? That's really close. Is it? Is it really? So error opening this. So temp. So error opening. Is it error opening because it's we don't have file permissions? Error opening. So it just says error opening. And if we try running it on well, I mean, let's just try opening up etc shadow. It's also going to give the error opening etc shadow. So it says error opening etc shadow, but we'll try this. So I think this should be the file that we created. Error opening, but it doesn't give the name. What happens if we give Narnia pass Narnia 4? Chmod for the link? Oh, maybe. Yeah, it says error opening this. Okay, so let's quit out the link file. Let's take a look at the file permissions on that. Temp ... Narnia 3. Well, I mean, they're pretty open permissions here. We can read, we can write. Wait, is this a directory? No. Hold on. Yeah, this is a link. It's got all the permissions. And it redirects over to Narnia Pass. Hold on. There's one last thing. It might be that this is one character too long, because I noticed that stuff was getting cut off. Let's echo it out to make sure that this is, what is it, 32? Nope, we need to word count 32. Okay, let's go back in. Cannot open. Cannot open temp Narnia 3 this thing. Let's load it in. Oh, I'm not even running Radari 2 right now. Oh, you know what I forgot to do? I forgot to run Radari 2 in debug mode. Okay, if we just run the program, it says error opening. Okay, let's reload it. And then we'll set our breakpoint. PDF at main. So it's, let's see, just says error opening. here. We'll set our breakpoint beforehand. Run it, hit the breakpoint, px at ebp minus hex 18. Okay, dev null. Yeah, I think it's one character too large. So the other thing is the 58. Yeah, so we fit it in here, but it's one character too big because it starts overwriting into this variable here. So we need to create a new symbolic link, but we need to make it one character less, which is kind of annoying, but what are you gonna do? Exit. So where's my symbolic link command? Here it is. Okay, we just need to make it one character less. Okay, then we do the same thing, but we feed it the other command. Chmod 777 the file. I think it already comes chmoded because I'm pretty. It already comes chmoded. Okay, let's just run this thing. Error opening. Error opening and then process exited. So the reason why it had error opening is because this is a symbolic link. And the symbolic link it's a symbolic link to a file that we don't have permissions for. So that's the no-go. But let's see if we can feed it something else. So let's see, slash the other thing, temp Narnia 3. What was the name of it? What are the name of those files? So ABC, ABCD or something? Okay, let's OOD this. Process terminated. Okay, and then let's assume that 32 bytes path you gave is a junk payload A, then you need the correct path to overflow the output file. Let's say temp. If you want to see what's missing, Perplexity AI. Okay, hold on. Let me take a look at Ronan's link. Thank you very much, Ronan. Much appreciated. I've got 3 minutes to solve this. Okay, so what's going on here? Good old AI. Simplified explanation of the Narnia 3. Extract the password and read the next level by reading the file. The vulnerable program copies the contents of the file that you specify, input, into another file, output. By default, the output file is set to dev null, which discards the data. There are 2 string buffers, I file, which holds the path for the input file, size 32 bytes. O file, which holds the path for the output file, size 16 bytes, K. You need to create a symbolic link on the 37 bytes folder to the password. The 37 bytes folder to the password. Let me read the rest of this. Provide a very long input file path that fills I file exactly and continues to overwrite O file with the path that you control. Okay, step-by-step walkthrough. Make a long directory name for the path. Yeah, okay. Create a symbolic link inside this directory to the password file. and then chmod it. Now this chmod, make the link and then chmod it. I mean, the thing about what's happening right now is that we've already have full permissions on these links. So that isn't necessarily the problem. Now this points to the real password file. Okay. Run the vulnerable program with the crafted argument. Read the password from the output file. Why this works. Why this works, you say. Okay. Let's say that you create a symbolic link. Path to the pass, the key. Path to the pass, the key. The problem is that this approach reveals the password to the next level. Okay, I think I might have to take a look at a write-up after this, because this is pretty devilish. Okay, so I feel like we got really close. The problem, the big problem that I see right now is that we don't. The program can't read this file. It can't read the password file. You know what? You know what we should do? We should read the password file for our level, or we should just read any file, and then we can see if it works that way. So I just want to do this really quick, and we'll make the link to Narnia 3 instead. Okay, let's make the link to Narnia 3 just as a proof of concept. Okay, so this is the shorter file name. Okay, so we'll use this as the file path, and so if this is the file path, then we'll provide the path to a file that we control, which is ..Narnia 3 this one. And let's just get the length of this string. So this is 50. I mean, 50 is fine. It doesn't need to. This part of the payload doesn't need to fill up. It doesn't need to fill up the buffer. Okay, so this is our payload now. Redirect to debug Narnia. Actually, wait. Let's just try running it. Narnia 3 with this. Error opening. Oh. It didn't get this correct. Okay, so it needs to be one. This needs to be still one less, because it wasn't able to get the slash. Okay, so we'll just we'll make another link, but it's going to be still one less, which is, I don't know, like this. That leads to Narnia 3. Okay, in which case the payload is Where is that link? Link is to N. Error opening. Oh. Why is it getting shorter now? Do I need to make my link longer? You need one more. You need one more. Okay, so let's try this then. Error opening, what was it? Error opening temp Narnia 3, this thing temp Narnia. Ooh. Yeah, we need in this case we need like a null byte or something to separate this. Temp Narnia something something, and then this gets garbled. Actually, error opening temp Narnia 3 AB. Okay, so temp Narnia 3 AB works. We just need to make that file. So, or let's just touch it. Touch /AB, and then run the thing again. And now it says error opening garble garble. Oh man, this directory is such a mess now. Oh well. Lodwig, hello. Did you put in a working payload in here? Let me know if you did. Let's take a look. Ah, I see. Let's see, etc. Narnia past Narnia 4 to Lodwig. Okay. I'm gonna have to wave the white flag. You solved it. Wait, give me your payload. Copies of contents Lodwig AAAAA temp the key to a safer place. Temp the key. Okay, so you created a temp Lodwig AAAAA directory? Okay, let me take a look at this. Echo this thing. Word count. This is 44. 44. So this is the directory. This is 32. Okay, so this is 32. Temp the key, and then the key will have temp Lodwig AAAA, and I'm assuming that this is the symbolic link. No, this is a directory. So, wait, what did the full temp the key? The key... So this thing, The symbolic link is on the temp. Really? Hold on. Temp. Oh, you know what I see? Wow. Wow. So it's a file called /temp Ludwig temp the key. That's the symbolic link. Okay? I mean, wait. So where does the file get copied to, or where does the copied content go to? So you're copying from this thing, but where are you copying it to? Or does it just output to standard out? Narnia 3 this copied the contents to a safer place. So it copies to temp the key. And this is the password for the next level, and then a bunch of garbage for some reason. Oh, wow. 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 I was... So we need to make this whole thing... We just provide one argument here, and this whole argument becomes a symbolic link. No, don't say I'm the real hacker when you when you solve the challenge. Don't do that. Don't do you know, I'm glad we were able to see the end of the challenge without having to look at a write-up, so that's nice. But yeah, I'm going to be taking a look at this after the stream. We don't have... I have to go and eat dinner now. It's really late. It's really late. It was really confusing, you know, but I think we got some good study out of this. I think we learned a thing or two about how these kind of vulnerabilities could work. I don't know if I'm going to see like a challenge like this, similar to this in the future, but it's good to be able to say that you solved something like this. Okay, so what are we doing next time? So this is Friday. You deserve that dinner, Mr. Frog. Thank you. I need to work for my dinner. 43. Okay, so this is week 43. There's only 10 weeks left in the year. That's really surprising. There's 52 weeks in a year. It's already week 43 next week. But yeah, we're going to be finishing off 20 small mazes on Monday after the weekend, and then we're going to be doing Web App Hacking 6. This is going to be SQL injection. I think it's going to be, let's see. It's going to be filter bypass, and I don't know if we're going to be doing Union SQL injection in this one or not. But yeah, SQL injection in the next HackerFrogs AfterSchool. So we're going to be doing more Hades CTF labs. These are demos for privilege escalation stuff with Linux. And we're going to be doing another difficult challenge from Volnix.com. So please look forward to that. And let's see if we can find some people to raid. Panko, are you still here? Do you want to go online? I could raid into you. Okay, Jay Beers, right. We were asked by Agent 57 to raid into Jay Beers. So let's check out what they're doing right now. I hope you all get to learn it. Okay, so it's an adults only hacking stream. Okay. I see. Well, Mind of a Hacker OSCP study, great. All right, let's go ahead and raid into Jay Beers. Let's start that raid. Raid J Beers 11. Okay, everybody. Thank you very much for everybody for watching today. We did a lot of head banging against the wall, but hopefully we learned a thing or two about binary hacking stuff. But yeah, have a great weekend. Oh, taking terminals. Oh noes. Anyways, let's see. He's at Walmart and we'll be back soon. Oh, okay. All right, everybody. We're gonna raid into the channel, and yeah, thank you very much to Ronin and MC25, Saint of Vice, Henky Lodwig, and everybody else who participated in today's chat. All right, everybody, ready for the raid? 3, 2, 1. HackerFrogs raid. Have a great weekend.